Hello there and welcome back to the Sleep Science. Tonight you wake up inside a universe that's running out of surprises. The stars above you seem just a little dimmer than you remember, and even the cosmic microwave background hum, the leftover echo of the Big Bang, feels tired. It's as if the whole cosmos has exhaled and forgotten to breathe back in. You probably won't survive this, by the way, not because something dramatic is coming, but because slowly dying is the universe's most patient hobby. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Go ahead and drop your location and local time in the comments. I always love seeing where everyone's listening from, whether it's a neon-lit city at midnight or a quiet farmhouse under the stars. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You stand on a shoreline of cosmic sand and the tide is time itself. The horizon glows not with sunrise, but with the residual warmth of everything that's ever happened. This isn't the fiery chaos of creation. It's the slow, stretching sigh of entropy doing what it does best, spreading, smoothing, and stealing every sharp edge it can find. You reach down, scoop a handful of that sand, and watch as it slips through your fingers, each grain a little atom of order giving up its ghost to disorder. Entropy, the quiet accountant of existence. It's the reason your coffee cools, your phone battery drains, and your body, yes, even that, is constantly falling apart molecule by molecule. The second law of thermodynamics doesn't shout, it just whispers, you can't win, you can't break even, and you can't get out of the game. That law is what every star, every planet, every living cell obeys without exception. Far above you, the cosmic background radiation hums at about 2.7 Kelvin. That's only a few degrees above absolute zero, but it wasn't always so cold. Once, that same radiation was blinding white hot, a dense roar of light. But as the universe expanded, the wavelength stretched like taffy. The once brilliant fire faded to a faint microwave glow, like the dying embers of an ancient campfire nobody remembers lighting. Historians still argue whether the early scientists who first measured that glow truly grasped what it meant. When Arno Penzias and Robert Wilson detected the cosmic microwave background in 1964, they thought it was pigeon poop on their antenna. Turns out it was the universe saying, hey, I've been cooling down for 13.8 billion years, thanks for noticing. You start walking, if you can call it that, in the slow drift of space. The airless dark doesn't resist you, it simply allows. Behind you, the Milky Way smears itself into a soft ribbon of light. Up close, stars burn ferociously, but from here they seem fragile, like candles in a cathedral so vast the heat never reaches the walls. There's an odd comfort in realizing that the same laws that govern a dying star also dictate how your body loses heat on a cold night. That balance between energy and entropy connects everything: soup, stars, and smartphones. In the 1800s, Lord Kelvin described heat death as the inevitable destiny of a universe running out of free energy, the moment when all motion, all difference, all possibility of work ceases. You might picture that as a grand finale, but really it's a fade-out, a universe falling asleep. And here's a strange tidbit. In the 1850s, some thinkers worried that if the universe were eternal, it should have already reached that final chill. That little paradox, known as the thermodynamic age problem, was one of the clues that our universe actually had a beginning. Without entropy's trail of breadcrumbs, we might never have realized that time itself started somewhere. But tonight you don't need equations, you just feel it. The air, or the absence of it, seems to thicken. Every photon that touches you is a little older, a little redder, its energy diluted by the expansion of space. You imagine entropy as an artist who paints in greys, smoothing every contrast, blending every bright thing into the same soft tone. You glance at a nearby galaxy, its spiral arms thinning like the slow unraveling of a threadbare sweater. Inside, billions of suns live and die, each one releasing energy that can never be fully reclaimed. The universe doesn't destroy energy, it just spreads it too thin to be useful. Think of it as cosmic laziness, or maybe cosmic balance depending on your mood. A rogue joke drifts by, unbidden. If the universe is dying slowly, then technically you're procrastinating in perfect harmony with it. You chuckle softly. The sound doesn't travel far here, but the thought warms you for a second before entropy claims that too. Still, there's beauty in this slow unraveling. The same principle that guarantees eventual silence also allows the symphony to play in the first place. Without Entropy's one-way march, time would have no direction, and nothing could ever change. There would be no beginnings, no middles, no sleepy endings, just frozen symmetry, as lifeless as a paused video. Somewhere, a supercluster of galaxies stretches like a great cosmic web. The distances between its threads are growing, pulled apart by expansion. It's said that in a few trillion years, most galaxies will drift beyond each other's light, each island forever alone in the dark sea. But right now, this cosmic blink, we still see them, still feel their warmth, still whisper about their fates. You look back once more, and the universe looks like an enormous hourglass. Except this one doesn't run out of sand. It just keeps thinning it out until it's evenly spread across infinity. Your eyelids grow heavy as that thought settles. The stars seem closer now, maybe because they're fading at the same pace as your awareness. Entropy isn't the enemy. It's the reason anything happens at all. It's motion, memory, music, all decaying, yes, but beautifully. You take a slow breath, or the dream equivalent of one, and let the warmth of those dying photons wash over you. They've travelled billions of years to find you here, just to tell you a single truth whispered through the static of space. Everything ends, and that's okay. You keep drifting in that faint afterglow wrapped in the universe's tired warmth. Every breath, or whatever counts as breath here, feels like it's been borrowed from an older fire. Entropy's whisper still lingers in your ears, and you realise that to understand how everything fades, you first need to understand the rules behind the fade itself. The universe, as it turns out, has a manual, and the first few pages are labelled The Laws of Thermodynamics. They sound dry, sure, but they're the secret poetry of existence. The first law tells you that energy can neither be created nor destroyed, only transformed. You can't get something from nothing, but you can trade one kind of something for another. The second law, our old friend entropy, declares that energy spreads out, loses focus, and becomes less useful over time. And the third law insists that as you approach absolute zero, motion itself comes to a halt, though that's more of a theoretical dare than a reachable goal. You float beside a vast chalkboard etched across the night sky. Someone, perhaps the cosmos itself, has scribbled the equations of energy balance there. Joules, kelvins, entropic gradients. It all looks intimidating until you notice the doodles in the corners, a steaming cup of tea, a melting ice cube, a sun setting behind a horizon. That's when it clicks. Thermodynamics isn't about abstract math. It's about everything that ever cools down, runs out, or gives up heat. You picture yourself making coffee. Freshly brewed, it's a bubbling microcosm of order, hot liquid, low entropy. But the moment you pour it, it starts to even out with the air around it. The steam rising from the cup is your own personal demonstration of the universe's destiny. Energy spreading out, seeking balance. Give it 10 minutes, and that once passionate mug becomes lukewarm indifference. Just like cosmic background radiation, only caffeinated. A historical image flickers by. James Joule in his 19th century workshop, carefully measuring how mechanical work turns into heat. He used a falling weight to stir water, proving that motion and temperature were two sides of the same coin. The idea that energy could move between forms but never vanish was revolutionary, like discovering the universe had a savings account it never closed. Joule's simple paddle wheel experiment was the ancestor of every car engine, every power plant, every human attempt to squeeze more order from chaos. Still, you can't cheat the house. Every energy exchange has a tax, and entropy is the collector. Historians still argue whether the laws of thermodynamics describe an inherent cosmic doom, or just our local perspective of time. Maybe they say entropy isn't the end. Maybe it's a record of how information changes hands. Either way, the receipts are piling up. You step onto a giant iron plate floating in the void. It's warm beneath your feet, someone's imaginary experiment in progress. A furnace blazes at one end, radiating heat. The other end glows faintly blue from the cold. The heat drifts inevitably toward the chill, evening things out. The energy isn't gone, it's just lost its ability to do anything useful. You watch that balance form, and for a moment it's beautiful. A cosmic exhale frozen in motion. A quirkier thought enters your mind. Once upon a time, medieval alchemists tried to invent perpetual motion machines. Wheels that would spin forever, fountains that would flow without pumps. They failed, of course, because the second law always wins. The closest anyone came was a 12th century design by Villard de Honnecourt, a wheel filled with swinging hammers that was supposed to keep turning under its own imbalance. It didn't. Entropy chuckled quietly and went back to sleep. You imagine showing one of those alchemists your smartphone. Look, you'd say, a tiny universe where information burns electricity. They'd call it magic. You'd nod and say, it is. But the battery dies eventually. Same rule, different gadget. You reach your hand into a current of light that passes by, photons streaming from a distant star. The light feels warm, then fades. You realize that even starlight obeys these thermal rules. When energy travels, it dilutes, cools, weakens. The night sky is a museum of expired thermodynamic opportunities. Every gleam you see is work already done. Heat spent, motion converted, entropy increased. Another figure joins your reverie, Rudolf Clausius, the man who gave entropy its name. In 1865, he wrote that the energy of the universe is constant. The entropy of the universe tends to a maximum. That phrase is as elegant as it is grim. It means that while energy can never disappear, its usefulness always declines. The cosmic battery is eternal, but its charge is always draining. You catch yourself smirking. So, you think, the universe is basically my phone after a long day. There's your first gentle joke of the night, and the stars seem to twinkle a little brighter for it. Maybe they appreciate being compared to dead batteries. Still, there's something oddly comforting in the inevitability of it all. If entropy must increase, then every warm moment you feel is precious precisely because it won't last. Every flicker of energy is a miracle against the background of the cold. Entropy makes value possible. You drift lower, touching a patch of cosmic dust. Tiny particles bump and jostle, exchanging heat, following invisible gradients toward equilibrium. You could watch them forever and never catch one breaking the rule. Even when life appeared, when chemistry learned to fight entropy temporarily by feeding on sunlight, it was only borrowing time. Organisms, after all, are just local order machines powered by global chaos. Thermal death sounds dramatic, but the truth is far more serene. The universe isn't rushing toward its end, it's reclining into it. Like a fireplace fading to embers, it's giving off its last warmth with quiet dignity. A random thought. Maybe that's why humans are drawn to warmth, to fires, to blankets, to other bodies. Deep down, every living thing knows it's fighting the cold end of everything, so we gather heat wherever we can find it. The cosmos around you glows faintly orange as if agreeing. For now, stars still burn, molecules still move, and your own atoms still hum with borrowed warmth from the Big Bang. But the rules remain in place, quietly counting down every joule. As you drift through the black, you find the comfort in understanding the inevitability. Thermodynamics isn't cruel, it's consistent. The first law promises nothing is truly lost. The second promises everything changes. And between those two promises lies all the warmth, motion, and memory the universe will ever have. The last thought before you let yourself drift further. Entropy may guarantee the end, but it also guarantees the journey. And tonight, you're along for the long, slow, glowing ride. You open your eyes again, or maybe they were never closed, and find yourself inside a vast glass hall that hums with faint machinery. The air smells like heated metal and cool steam, as if the whole place exists halfway between boiling and freezing. The words engines, ice, and irreversibility shimmer faintly on the wall, but you know this isn't a title, it's a mood. You've stepped into a dream built from pistons, pipes, and paradoxes. Rows of ancient contraptions line the hall, brass engines, glass tubes, spinning flywheels. Every one of them pulses with the same secret heartbeat, the one that says you can trade heat for work, but never all of it. The sound is soft and steady, like a tired sigh repeated endlessly. Somewhere, a single droplet of water falls onto hot metal and vanishes in a hiss, the briefest reminder that every transformation has a cost. You walk between the machines, tracing their warm sides. You recognize some names on little plaques: Carnot, Clausius, Kelvin, the pioneers of thermodynamics, the people who turned fire and ice into equations. Their discoveries shaped everything from steam engines to spacecraft, and they all whispered the same truth, that once energy takes the form of heat, some of it is gone for good. No amount of cleverness can unboil the universe. In the middle of the hall sits the Carnot engine, a dream more than a device. You kneel beside it, watching imaginary pistons rise and fall in slow motion. Sadi Carnot, the French engineer who imagined it in 1824, wanted to know how efficiently an engine could ever run. His answer wasn't about technology, it was about nature's limits. Even in perfection, no machine could turn all heat into work. Some must always escape as waste, as entropy's toll. It's funny. Every steam locomotive that thundered across continents, every generator that powered a city, all of them were just trying to cheat that same law a little better. But the universe doesn't negotiate. It just smiles, takes its cut, and moves on. You wander toward a column of cold vapor swirling up from the floor. When you touch it, it feels like the breath of time itself. Soft, irreversible. The steam curls, fades, and merges with the air, never to reassemble as it was. You can imagine 18th century scientists staring at melting ice cubes, watching their ordered crystals surrender to disorder, realizing that something irreversible was at play. Once the cube is gone, it's gone. There's no reverse melt button. There's a comforting logic to it, though. Without irreversibility, time would have no direction. You wouldn't know yesterday from tomorrow. There would be no reason to move forward at all. Historians still argue whether entropy causes time to flow or merely follows it like a shadow. Either way, one makes the other visible. You move forward because the universe insists on decay. The hall shimmers again, and suddenly you're standing beside a frozen pond in some timeless evening. You kneel and trace a finger through the thin ice, watching ripples distort your reflection. Beneath, the water waits, dense, dark, and almost motionless. It's strange how freezing and melting, opposites in temperature, both feel like acts of surrender. One to stillness, the other to diffusion. Either way, energy slides toward equilibrium. You recall a small, deliciously odd historical fact. In the 1600s, Dutch merchants shipped blocks of ice from Norway all the way to colonial India just to cool drinks for British officers. Thousands of miles of melting proof that even luxury obeys thermodynamics. A bizarre global dance of heat and loss. Ice melted along the way, of course. Entropy doesn't respect colonial schedules. You stand again in the machine hall. A door at the far end has the faint shimmer of a mirage, and beyond it, you glimpse vast fields of engines, steamships, power plants, the glowing circuits of modern computers, all performing the same cosmic ritual, burning order to do work. The Industrial Revolution, you realize, wasn't just about human progress. It was entropy made visible on a planetary scale. And here comes your first small, sleepy laugh of the section. The entire human species, proudly building machines that heat the planet faster, all to say, look how efficient we are. It's a kind of cosmic irony, like running faster toward a treadmill's end, but it's also beautiful, because in that endless conversion of heat into motion, we find purpose, temporary, flickering, but real. You look down again at the floor, now covered with a thin layer of frost, as if the universe itself is cooling beneath your feet. Somewhere nearby a single gear clicks, then slows. You sense the meaning behind that sound. Every act of creation adds a little to the cosmic bill. Every flame, every breath, every heartbeat pays tribute to entropy's treasury. In the corner of the hall, a curious exhibit glows. It shows two paths, one where ice melts, and one where it spontaneously refreezes. The second path looks strange, unsettling, like watching rain fall upward. Mathematically, it's possible, but the odds are so astronomically small that the universe treats it as forbidden. Irreversibility isn't absolute law, it's overwhelming probability. Yet that's enough. A small plaque at your feet reads, "The universe has no rewind button, only pause and play." You smile, because whoever wrote that understood everything. As you wander toward the far door, a voice, maybe Carnot's, maybe your own, whispers, "Work is order turned to motion, heat is motion turned to rest." You nod. That's the trade that makes stars shine, engines run, and hearts beat. You step through the door and feel a chill breeze brush your face. The engine hall fades, replaced by a quiet, snow-covered landscape. Somewhere in the distance, a frozen river reflects starlight. The air feels perfectly balanced, neither warm nor cold, neither still nor moving. You realize this balance, this calm, is entropy's destination. The universe's longest sigh. As you start walking across the snow, your footprints fill in behind you, erasing themselves. Irreversibility's final joke. Even evidence of your passing fades with time. You don't mind. There's a strange serenity in knowing that every action, no matter how small, ripples forward, never backward. Every choice, every motion, a one-way ticket through a cooling cosmos. And you're here for the ride, tracing the patterns of loss that make life sparkle. Ahead, the snow begins to glow faintly orange, as if reflecting distant starlight. The warmth calls you forward, toward the next place, the next whisper in the universal hum. You follow that faint orange glow until it becomes a flicker, and then the flicker turns into a candle flame. Though who would light a candle in the middle of cosmic night? The air around you feels heavier now, thicker with thought. The glow isn't from wax or wick, it's from memory. You're standing inside the mind of a man who tried to measure the chaos itself, Ludwig Boltzmann. He's hunched over a desk, ink-stained fingers trembling above a sheet of paper. Outside his window, Vienna's gas lamps hiss, painting the streets in smoky gold. You don't need to read the notes on his desk to know what they say. The equations of entropy, those same terrible, elegant hieroglyphs that explain why order always dissolves. Boltzmann's dream was to give mathematics a soul, or maybe to prove that the soul was just mathematics. You step closer. He's scribbling S equals KL N WS equals K LN WS equals KL NW. That small, perfect equation carved into the tombstone of physics itself. It means that entropy, S, is tied to the number of possible microscopic arrangements, W, a system can have, multiplied by a constant K, which forever bears his name. In plain words, the more ways something can fall apart, the more likely it will. It's a grim epiphany wrapped in beauty. You watch him pause, stare at the page, and sigh. He's realized that disorder isn't a failure of nature, it's nature's preferred state. Perfection is rare because it's fragile. Chaos wins because it's abundant. Historians still argue whether Boltzmann truly believed that the universe's ultimate end was irreversible, or if he held a secret faith that new order might spontaneously arise again, randomly, improbably, like a phoenix from heat death's ashes. What's clear is that his contemporaries thought him almost heretical. In the late 19th century, when determinism ruled science like a monarch, the idea that atoms could dance to the tune of chance, probabilities not certainties, felt scandalous. You drift around the room, touching the air near the chalkboard. Dust motes hover like frozen sparks. Each one seems to represent a possible configuration of reality, flickering between existence and absence. Boltzmann saw this not as philosophy but as counting. If there are more ways to be disordered than ordered, the future belongs to disorder. The candle of his mind flickers brighter, and suddenly you're no longer in the study. You're in a vast amphitheatre made of equations and whispers. All around you, imaginary particles bounce and collide in endless motion, a grand statistical ballet. It's both chaotic and perfectly predictable in the long run, entropy increasing, temperature evening out. A voice, calm, almost paternal, fills the air. The probability of order is not zero, it's just unfathomably small. You recognize the tone. It's Boltzmann himself, or at least the echo of his ideas. He's reminding you that the universe could, theoretically, reassemble itself into something ordered again. A random fluctuation could reverse the arrow of time for a heartbeat, but it would take longer than the lifetime of all known galaxies multiplied by themselves 1 trillion times. So yes, it could happen, but no, you shouldn't wait up. You smile at the absurdity of it, a small joke sneaking in. Somewhere, a Boltzmann brain might pop into existence, a self-aware mind born spontaneously from random quantum chaos, only to vanish again before it can finish its first thought. Cosmologists still debate whether that idea is profound or preposterous. Either way, it's the kind of bedtime story that makes the universe both terrifying and strangely comforting. You walk through the amphitheatre as the equations dissolve into stars. Each glowing symbol becomes a sun, each exponent a galaxy. Boltzmann's mathematics stretch across space, connecting every flicker of heat and light. You realize that entropy isn't destruction, it's distribution. It's the universe's way of sharing the load. But back in Vienna, Boltzmann's world wasn't so kind. His theories were dismissed, his probabilistic worldview mocked. In an age that worshipped order, he saw only inevitability in disorder. His story ends tragically. He took his own life in 1906 while vacationing by the Adriatic Sea. It's said he had just written letters defending his ideas one last time. The cruel irony, within a decade Einstein and others would confirm his vision of atoms and statistical mechanics. You feel a pang, a mix of sorrow and admiration. The man who proved that the universe tends toward randomness was himself undone by the chaos of disbelief. But you also sense that he understood something deeper, that even despair follows thermodynamic law. Heat dissipates, emotions fade, and yet the equations remain, serene and unbothered. As you walk out of his room, you glance at the window once more. Outside, the night has deepened, but the stars above seem to pulse in silent applause for the man who gave them meaning through numbers. Every sun burning in that infinite sky is a living demonstration of his equations, matter organizing itself temporarily against the tide, just to glow for a while before surrendering. You step into the street. The cobblestones beneath you radiate faint warmth from the day's sunlight, still bleeding energy into the cool evening air. Somewhere nearby, a carriage rumbles past, its lamps flickering like two golden eyes. Even that small act, the horse's muscles, the turning wheels, the fading heat, is another stanza in Boltzmann's grand poem of Entropy. And maybe that's the secret comfort of his legacy. You don't fight entropy to win, you fight it to live. Every breath, every heartbeat, every flicker of thought is a rebellion measured in microseconds against the inevitable. As you drift onward, the Viennese night blurs into a dark sea of stars. The candlelight fades, replaced by the far more ancient glow of galaxies. You realize you've been following Entropy's trail all along, not as a doomsday countdown, but as a map of everything that ever happened. You float there a while listening. The universe hums softly like a candle burning far away. Somewhere Boltzmann's equations still whisper through the void, reminding you that even chaos is a kind of order, just the kind too vast for comfort. And when the last echo fades, you whisper back, "I understand, though you know you really don't. Not yet." The Viennese night drifts away, dissolving into black sky flecked with silver streaks that look suspiciously like seconds escaping through cracks in time. You're weightless again, wrapped in a current that moves only forward. Somewhere out here, Boltzmann's equations stretch into infinity, and you feel them tug at you like a tide. The arrow of time, capital A, capital T, has found you. At first it's gentle. The stars seem to slide in one direction, as if the entire universe were a great slow river, and you were a leaf on its surface. You can almost imagine turning around, paddling upstream, unmelting an ice cube, relighting a burnt-out match. But when you try, the current simply thickens around you, firm and quiet, no rewinds allowed. Time, it seems, behaves like an obedient servant of entropy. Historians still argue whether entropy creates time's direction, or merely rides along with it, like dust swirling behind a carriage. Whichever it is, you're caught in its wake. Everything ahead of you is messier, everything behind you was once neater. You can trace the asymmetry in your own bones, the way scars never unform, the way memories only grow heavier. A sudden shimmer unfolds before you, the great archive of broken clocks. Thousands float around you, each stopped at a different moment. Some tick backward for an instant, then freeze again, as if mocking the very concept of reversal. Their glass faces reflect your own expression, half awe, half mild irritation. "So," you mutter, "time really is just Entropy's favourite playlist." You reach out and touch one clock. The instant your fingers brush its surface, the hands leap forward in a blur, years flashing by in seconds. You see empires rise, stars ignite, glaciers melt. The motion ends in silence, a clock hand resting exactly at 12, midnight or noon, depending on your optimism. A warm voice interrupts the stillness. It's familiar, but you can't quite place it. Maybe it's time itself. "You can slow me," it says, "but you can't turn me back." You realize that's true on every scale. In the laboratory, physicists can cool atoms, slow reactions, and even mimic backward behavior in quantum systems. But the overall entropy still climbs. The house always wins. You stroll through the archive feeling a peculiar nostalgia for moments you never lived. Each frozen clock is like a fossilized breath of the universe, order captured mid-collapse. Some ticked during the fall of Constantinople, others during the birth of the first star. All of them point in the same direction. The air hums, and you're suddenly standing in front of a giant hourglass the size of a galaxy. The upper chamber glows gold, the lower one blue-black. Between them trickles a stream of shimmering particles, tiny suns, burning briefly before fading into dust. The arrow points downward, of course. You know it can't go the other way, but just for curiosity's sake, you flip the whole thing over. Nothing happens. The particles continue falling in the same direction, ignoring your rebellion. You can't help but laugh, softly, tiredly. "Fine," you whisper. "You win." As if rewarding your resignation, the hourglass transforms. You're now surrounded by scenes from everyday life, each one illustrating irreversibility with small domestic poetry. A child's dropped ice cream, a wilted bouquet, a balloon sighing out its last bit of helium. Each vignette is funny in a tragic little way. In one corner you see the universe's earlier seconds playing out like a silent film, the Big Bang expanding, cooling, forming stars, planets, people. The entropy rises frame by frame until it merges with the darkness you're floating in now. It's odd how comfortingly familiar that darkness feels, like the universe's version of bedtime. For a heartbeat you wonder, if entropy writes time's script, could there be another kind of time, one running in reverse somewhere else? Some physicists suggest that another universe might exist on the other side of the Big Bang, where time flows backward relative to ours. You picture mirrored galaxies, mirrored lives, mirrored you, someone out there watching suns unset, ashes reforming into trees, lovers meeting by forgetting each other. It's so delightfully absurd you almost hope it's true. A bright point flashes in the dark, the briefest glimpse of a supernova tearing itself apart. You realize that every explosion, every irreversible act marks time's passage. Without decay, there'd be no heartbeat to measure it by. In a way, entropy is the universe's metronome. You drift onward and find yourself inside a long corridor lined with mirrors. Each reflection shows a younger version of you, less worn, more curious. When you turn to face the youngest, the mirror fogs, instantly erasing it. That, you decide, is entropy's punchline. The more you try to hold on, the faster it slips. But then the mirrors shimmer again, and for a fleeting second you see all versions of yourself simultaneously. Child, adult, dust. They blur together until only one thing remains. The feeling of moving forward through something irreversible but not cruel. Time isn't an enemy, it's a direction carved by heat and chance. Another small joke sneaks in as you step out of the corridor. If time is a river, then I'm definitely the person who forgot their floaties. The universe chuckles faintly in the static of background radiation. You find yourself now beneath a sky that seems to ripple with clocks made of constellations. Each star ticks once per millennium. You stretch out a hand and feel one pulse fade, another ignite. The pattern repeats endlessly, reminding you that even dying light contributes to the grand forward march. At last, the current begins to slow, the stars settle, the black between them deepens, and you realize that time's arrow isn't about urgency, it's about inevitability. You don't need to race it, you just need to notice it passing. Before you drift entirely into stillness, a final whisper trails through the dark. Forward is the only way to fall. You smile, letting the words echo once before they too dissolve into thermal equilibrium. You float at the edge of a dim nebula, a ghostly curtain of pink and blue gas draped across the velvet black. It smells faintly of ozone and ancient dust, a place where stars are born, live and die in slow motion. The hum beneath everything, the constant low vibration of heat and light spilling from every atom, reminds you of breathing. Except this time, it isn't yours. It's the universe exhaling through its stars. You drift closer to one glowing cluster where newborn suns pulse behind clouds of cosmic soot. Each spark of light is a furnace, hydrogen crushed into helium under the weight of gravity. Fusion, the miracle trick that turns order into energy, mass into warmth. It's the cosmic equivalent of a campfire, and you hover close to one of those fires now, its surface boiling in a dance of plasma storms. The light is bright enough to make you blink, even here in your half-dream state. Every second, this star fuses about 600 million tons of hydrogen. Every second, it loses part of itself to brilliance. The light that touches your face left 100,000 years ago from its core, crawling slowly through the dense stellar interior before leaping into space at last. You are literally feeling the past in the warmth of the present. It's easy to forget that this whole fiery spectacle is just entropy at work, order being converted to chaos, stored energy bleeding into the infinite night. Stars are engines, and engines obey thermodynamics. Their heat, their glow, even their death are dictated by the same equations that govern a cup of tea cooling on a kitchen table. Somewhere in your mind, you hear a voice reciting a fact you half remember from a late-night science documentary. The sun loses about 4 million tons of mass every second. The words sound absurdly casual, like saying someone misplaced a few pennies. Yet that's the cost of beauty, the constant release of potential, traded for light. Historians still argue whether early astronomers like Lord Kelvin and Hermann von Helmholtz truly understood what powered the stars. Before nuclear fusion was discovered, they believed stars shone by slowly contracting under gravity. Their math wasn't far off, but the timescales were all wrong. It wasn't until the 20th century that scientists learned the real truth. Stars are fusion bombs burning in slow, exquisite balance. You can't help but smirk as you imagine the sun writing a resignation letter to Entropy. Dear universe, I'd like to stop dissolving myself now. But of course, the cosmos doesn't take requests. Every spark that burns bright must dim. You move away from the newborn stars toward an older region of the nebula. Here, the colours fade to ashen grey, and the gas hangs heavy. In the distance, you see the corpses of dead stars, white dwarfs, neutron stars, silent reminders that the brightest lights always pay for their radiance. A white dwarf flickers weakly nearby, the skeletal remnant of a once proud sun. It's small, dense, and glowing from leftover heat alone. No more fusion, no more fuel, just stored energy slowly leaking into the void. It's still hot enough to vaporize anything that touches it, but compared to its youth, it's ancient and exhausted. You imagine billions of such stars scattered across the cosmos, each cooling over trillions of years until they fade to black dwarfs, objects that, as of now, don't yet exist because the universe isn't old enough for them. You let that sink in. The cosmos hasn't even reached middle age yet. Everything you know, every history ever written, every heartbreak and invention, all of it has happened during the bright noon of creation, and someday all those fires will go out. But don't panic. This isn't tragedy, it's temperature management. The universe isn't dying from violence, it's just running out of imbalance. When all gradients of heat and energy have evened out, entropy will finally rest. You can almost picture it. A cosmic night so calm that nothing stirs, nothing burns, and time itself takes a nap. As you drift past the faint glow of that white dwarf, you notice something odd. A distant point of light flaring and dimming in rhythmic pulses. A neutron star. You move closer, and the light becomes a heartbeat of radiation, steady and haunting. The remnant spins hundreds of times per second, magnetic fields lashing space like invisible whips. It's the ghost of a supernova, still keeping time long after the explosion that birthed it. For a fleeting moment, you feel an echo of admiration. Even in ruin, the star performs. It's as if the universe allows its dead to leave a song behind. That's the thing about entropy. It doesn't erase immediately. It lets the echoes linger. A historical tidbit bubbles up. Jocelyn Bell Burnell in 1967 was the first to detect these pulsing remnants, pulsars, thinking they might be alien signals at first. Imagine the irony, humanity listening to the last heartbeats of dead suns and mistaking them for greetings. A chuckle slips from you. The universe, endlessly patient, must have rolled its metaphorical eyes that day. The light from the pulsar washes over you in waves, each pulse a reminder of time's persistence. And you can't help but wonder, if entropy drives the universe towards stillness, why do stars exist at all? Why this brief, glorious rebellion of order against decay? Maybe that's the secret. Entropy isn't the villain, it's the scorekeeper. It allows moments like this to exist, fleeting and bright, before they fade. The stars aren't defying entropy, they're fulfilling it beautifully, turning potential into spectacle, chaos into warmth. The pulsar's light begins to fade as you drift farther. In its place, the nebula glows one last time, pale pink and violet, a cosmic afterimage. You realise that what you're seeing now is light that's been travelling for tens of thousands of years, a ghost signal from a past that's already cooled. Somewhere behind you, a new star ignites, brilliant and loud in its youth. You don't turn to look, you already know how the story goes. Every star is born with its obituary written in thermodynamic ink. Still, as that newborn blaze warms your back, you feel a strange kind of peace. Entropy doesn't kill beauty, it ensures it won't last, and that's what makes it worth noticing. You let yourself drift, weightless in the dim afterglow, the soundless hiss of starlight fading slowly into silence. You coast out of the nursery glow and into a wider, roomier dark where the universe feels comfortable. Not spry like a toddler cosmos, not creaky like a cosmic retiree, more like a 30-something galaxy binge-watching its own mergers while pretending it's still edgy. This is the galactic middle age, and you drift through it like a quiet guest at a neighbourhood block party where the grills are cooling and someone forgot to bring extra hydrogen. The sky around you is littered with islands, spirals, ellipticals, strange lopsided smudges, each a city of stars built inside invisible scaffolding of dark matter. They don't look tired exactly, but their energy is budgeted now. Star formation, once a reckless fireworks show, has settled into a slow, deliberate sparkle. Astronomers even have a nickname for the universe's earlier heyday, cosmic noon, when new stars blazed into existence at a rate several times higher than today. You missed the rave by a few billion years. Now it's a chill lounge with quiet synths and a bartender who's absolutely cutting you off at one more dwarf galaxy. You slide past one of those dwarfs, a puffball galaxy stitched together with hope and turbulence. It's hurrying along in the gravitational wake of a bigger neighbour, shedding gas like a nervous traveller spilling coffee. You can practically hear the gossip. The giant spiral whispers, "I might absorb you," and the dwarf blushes a blue hue, fresh stars popping in panic. Galaxies really do talk in a way. Their conversations are tidal pools and gas streams, subtle tugs that rearrange futures over hundreds of millions of years. Our own Milky Way sits in a comfy suburb called the Local Group, not far, cosmically speaking, from the urban sprawl of Virgo and nestled within the sprawling regional identity of Laniakea. You float over the quiet cul-de-sac where two heavyweights, Milky Way and Andromeda, eye each other across the street like future dance partners, pretending the slow song isn't inevitable. In 4 or 5 billion years they'll waltz, tangle and merge, star orbits scribbling bright calligraphy across the night. Don't worry, the stars inside almost never collide, it's mostly empty space. The drama is gravitational, not explosive, like a tense family reunion where no plates actually break. You can count that as joke 1, the universe gently smirks through 2.7 Kelvin lips. You brush the faint outline of the Fermi bubbles, those great ghostly lobes reaching above and below our galaxy's centre like afterglow bruises. They're relics of past activity, big galactic burps from the central black hole or from surges of star formation. Either way, your home galaxy has a history of flair. Middle age doesn't mean boring, it means fewer indiscriminate fireworks and more carefully scheduled pyrotechnics. You tilt your head and watch a parade of jellyfish galaxies, their star-forming gas ripped away by the pressure of hot intracluster medium as they rush through crowded clusters. The trailing tentacles sparkle with newborn stars, gasping luminous last stands. This is what passes for weather in the middle-aged universe, strangling winds, gentle strangulation by physics, and quiet quenching as fuel runs low. On cue, a panel slides open in the night and a footnote of memory pops up. Edwin Hubble, 1929, measuring galaxies receding, space itself stretching. A mainstream historical fact floats by with professorial gravitas. The universe is expanding, and farther means faster. Historians still argue whether Hubble deserves top billing, or whether Georges Lemaitre, the Belgian priest who published the idea first, should own the headline. Either way, the redshift chorus you hear now is the cosmic soundtrack of middle age, everything easing apart, politely, persistently. You drift through the colour-coded map in your mind. Blue cloud galaxies still forming stars, red sequence galaxies mostly done, the green valley, where many pass through that awkward in-between. It feels like walking a suburb at dusk. Kids have gone inside, porch lights are on, and the last frisbee arcs lazily across a lawn. The gas reservoirs that once fed Starbirth are dwindling or heated beyond usefulness, and massive galaxies shut down like retired factories, their lights on but machines idle. Now a quirky tidbit. Astronomers keep stumbling on ultra-diffuse galaxies, fluffy, faint puffs spread across areas as big as the Milky Way, but with a fraction of the stars. Some even appear to have unusually little dark matter, which is like finding a skyscraper mostly made of air and vibes. You squint at one such phantom and feel your eyebrows attempt a scientific double-take. The universe, midlife or not, still loves an oddball. You catch a wink from a faraway quasar, one of the ancient lighthouses powered by supermassive black holes greedily feeding. They're rarer now than in the boisterous youth of the cosmos. Middle age prefers quieter cores. Black holes still dine, yes, but often daintily, with jets and outflows that heat surrounding gas and shut down further star formation. It's a neat trick, a galaxy's heart teaching its disk to calm down. Your second gentle joke lands softly, galactic mindfulness training, but with plasma. The star-forming rate of the universe has been tapering for billions of years. JWST's keen eyes, peering back toward that raucous adolescence, have only underscored the contrast. Early galaxies were messy overachievers. Today's are tidier underachievers, polishing what stars they have and slowly cashing out their remaining hydrogen. Metallicity climbs as generations of stars forge heavier elements, oxygen, carbon, iron, then cough them into space. Your bones, your blood, your phone's screen, they're the dividends of stellar maturity. The party may be quieter, but the snacks are richer. You pass a spiral with a bar cutting through its centre, a stellar traffic pattern that funnels gas inward. Bars are middle-age features too, structural decisions galaxies make when the dance slows and self-gravity negotiates new routines. Beyond it, an elliptical lounges like a retired athlete, round, smooth, done with sprints. Its stars skew old and red, a population with stories etched in velocity dispersions. A memory threads back to Section 3's engine hall and Section 6's stellar furnaces. Entropy is still the background accountant here, totaling every photon spent. The lights dim not because someone flipped a switch, but because the gradient shrinks. Less cold gas, more warm equilibrium. Work gets harder when differences fade. Galaxies age because fuel balances out with need, like a campfire that's outgrown the woodpile. You pause to listen. There's a particular hush in midlife. Less crackle, more glow. Yet even now, collisions happen. Dwarfs are swallowed. Starbursts flare in brief rebellion. The universe hasn't gone quiet, just choosy. Your third joke drifts in like a comet. If galaxies had dating profiles, most would now say, looking for long-term stability, must enjoy low gas inflow and quiet evenings. You imagine swipes right measured in megaparsecs. Vera Rubin glides through your thoughts, late 1970s, calmly measuring rotation curves that refuse to fade at the edges. Her work revealed that galaxies are wrapped in halos of something unseen, dark matter, holding them together against centrifugal stubbornness. It's a mainstream fact with mythic resonance. The stage was always bigger than the spotlight. Middle age teaches that too. The visible blaze is never the whole story. The scaffolding matters. You sweep across a cluster where hot X-ray gas halos everything, a simmering bath that keeps member galaxies from cooling. Some ram through at high speed, stripped bare, others loiter and redden. The whole thing feels like an enormous retirement community with an unfortunately enthusiastic sauna. You can almost hear Entropy sigh, counting photons as they thin into the dark. Yet even in this slow fade, mischief persists. Rogue planets wander interstellar highways, molecular clouds occasionally squeeze out fresh stars, and somewhere, a radio mesa, natural microwave amplification by excited molecules, beams a tidy, improbable laser-like line across tens of thousands of light-years. The cosmos may be pacing itself, but it still throws glitter when the mood strikes. You realize, here in the universe's comfortable mid-afternoon, that endings are written in lowercase. The gossip of galaxies is gentle wind. The dimming is a lengthening shadow. Everything you're seeing is the second law, but played adagio. Heat spreads, gradients soften, work yields to warmth, and yet, what a view while it lasts. You drift on, letting the local group recede behind you, the Virgo cluster swell and then thin as you pass. The night remains huge and kind. Somewhere, far ahead on this one-way road, the fires will dwindle to embers, but you're not there yet. You're here, where the lights still chat across the void, where the middle-aged universe wears its years with quiet pride. You listen to that soft galactic lullaby and keep moving, slow as a thought cooling into memory. You glide onward until the lights of galaxies thin and something vast looms ahead, an ink-black horizon that swallows starlight whole. It's not empty though. It's brimming with secrets so densely packed they've forgotten how to leave. You've arrived at the cosmic vault of Entropy's most devoted collectors, the black holes. They aren't holes really, they're bruises on space-time, invisible and patient. Each one is a point where gravity wins every argument, even against light. The one nearest you hums like a distant cello, its pull shaping the surrounding stars into elegant, terrified spirals. You can feel its presence even from light years away, a weight in the air, a slow tightening of possibility. Black holes are Entropy's hoarders. They gather everything, matter, light, information, and compress it into absurd simplicity. From the outside, all that chaos looks orderly, a perfect sphere defined only by three numbers: mass, spin, and charge. No hint of the personalities that fell in, the universe's messiest closets, with doors that never open. You drift closer, and your stomach, if you still had one, tightens. The event horizon ripples faintly like dark glass. You reach out, not to touch because you can't, but to feel the boundary where time itself folds. The closer you come, the slower everything moves, like redshifts until even colour gives up. You realise you're watching Entropy's endgame, everything flattening, every detail smeared into sameness. A historical whisper floats through the darkness. 1783, the clergyman John Michel speculates about dark stars so massive that light can't escape, a concept 2 centuries ahead of its time. Later in 1916, Carl Schwarzschild solves Einstein's equations from a battlefield and gives these monsters their mathematical form. And still later, in 1971, John Wheeler gives them their unforgettable name, black holes. Historians still argue whether Wheeler coined it or merely popularised it, but you suspect the universe doesn't care who wins the credit, it just enjoys the drama. You circle the beast and watch its accretion disk blaze, a glowing halo of gas spiralling inward, heating to millions of degrees. It's like watching a campfire devour itself from the outside in. Magnetic fields crackle, X-rays flare, nearby stars tremble. Somewhere in that luminous ring, atoms are being stretched thinner than thought, their energy flung outward in desperate defiance. For a moment you see your own reflection in that spinning plasma, blurred, distorted, stretched into light years. The sight makes you dizzy, though not unpleasantly. It's entropy again, smoothing edges, trading individuality for equilibrium. Even your face, given enough time, becomes part of the background glow. You drift downward, no, inward, toward the event horizon. Around you, light bends like glassware underwater. A photon loops once, twice, maybe forever, unable to decide whether to leave or stay. It's a cosmic traffic jam of information, every bit slowed to eternity. Stephen Hawking's voice seems to echo through the void, gentle and amused. Black holes aren't entirely black. You can almost see him, seated in his chair beneath the stars, proving that even these ultimate traps leak a little. A faint trickle of thermal radiation. Hawking radiation, born from quantum chance at the horizon's edge, like the universe leaving a tiny tip after a massive meal. It's such a small effect that it would take longer than the age of galaxies for a black hole to fade completely. Yet that whisper of evaporation changes everything. If black holes can radiate, then information might not be truly lost, or maybe it is. Physicists still argue about it, like poets debating the colour of silence. Some say the data is encoded in the radiation itself, hidden in correlations too subtle for us to see. Others insist the information is gone forever, dissolved into probability. You listen to the debate echoing across space-time, both sides making good points, neither quite sure who's winning. You ease around to the dark side where the accretion disk's glow no longer blinds you. From here, the black hole looks perfectly still, a hole punched through reality. You imagine it not as destruction, but as storage. Everything that falls in isn't gone, it's archived in a format you can't yet read. Maybe entropy isn't about loss at all, maybe it's just compression. You remember the messy rooms and melting ice from earlier sections. All that chaos looked like disappearance, but what if it's just data rearranged beyond recognition? The black hole hums in agreement, or maybe it's just feeding. You decide not to take it personally. There's humour even here. Somewhere an astrophysicist is trying to model your fall on a supercomputer that cost more than your last 10 apartments combined. The equations grow wild, the singularities complain, and the simulation crashes. You grin. Even math has its event horizons. Around you, the space near the hole glitters with orphaned photons, light from stars that grazed too close and barely escaped. You catch one, metaphorically, and it shows you a ghost image. Entire galaxies mirrored, warped, lensed into crescents. General relativity, ever the show-off, bends reality just to prove it can. You recall a quirky tidbit. In 2019, humanity saw its first real image of a black hole, the one in galaxy M87, a glowing donut of doom 55 million light-years away. The Event Horizon Telescope stitched together data from across Earth, turning our entire planet into one giant eye. People cried when they saw it, not because they understood the physics, but because they recognized beauty and inevitability. You find yourself nodding at that. Beauty and inevitability, that's Entropy's love story. You drift closer still until the horizon fills your vision. The light fades to amber, then red, then nothing. You expect terror, but it feels more like surrender. Time stretches thin, moments separate like threads. You wonder if every particle that crosses this boundary feels the same peace. And then, right before the silence becomes total, the whole sings. A deep, resonant tone produced by the vibrations of space-time itself. Astronomers call it a ringdown, the final sigh after a merger. You just call it perfect. The sound fades, the dark expands, and you pull away, slowly, reverently. Behind you, the black hole gleams faintly, still feeding, still hoarding, still beautiful. You think about all the energy it's trapped, all the stories swallowed but not forgotten. Somewhere inside that silence, the universe is writing its final ledger in invisible ink. You drift away from that deep gravitational hum, the light of the accretion disk fading behind you, until it's no more than a flicker in your peripheral vision. You've been near the cosmic accountants, the keepers of lost heat, and now the universe feels strangely lighter, like someone opened a window after a long argument. Ahead, a faint shimmer ripples through the darkness, not of light, but of probability. Welcome to the playground where information itself tries to escape, the realm of the paradox. You coast into a hazy zone filled with what looks like soap bubbles made of equations. Each one trembles with half-formed possibilities, and when you peer close, you see snippets of Hawking radiation, tiny quanta fleeing the edges of black holes. They're weak, rare, but constant. Little cosmic gossip leaks, carrying whispers about what fell inside. You reach out to catch one, and it feels warm, warmer than the space around you, like a breath of truth wrapped in mystery. Stephen Hawking's ghostly voice returns, clear this time, reciting the line he once wrote with understated menace. If information is lost in black holes, then we are no better than classical physics. You can hear the grin behind the sentence. Classical physics hated losing things. The universe apparently doesn't mind. The information paradox is simple to say and impossible to solve. When matter falls into a black hole, its information, every quantum detail of what it was, seems to vanish. But quantum mechanics insists information can't be destroyed. Somewhere, somehow, the data must persist. The debate has raged for half a century, and historians still argue whether Hawking ever truly conceded that it might be preserved. The record says yes. The tone of his later talk says maybe. You drift among the glowing bubbles, each one representing a theory trying to patch the paradox. Some are elegant, others are hilariously desperate. The holographic principle hovers nearby, bold and shiny. All the information swallowed by a black hole is encoded on its surface, like a cosmic hard drive written in Planck-sized pixels. It's a deliciously weird idea, that the universe itself might be a projection, a three-dimensional movie playing from a two-dimensional screen. You imagine yourself leaning too close to the projector and whispering, "Hey, nice resolution." Not far away, a string theory bubble wobbles, singing in 11 dimensions you can't pronounce. It claims that quantum vibrations along infinitesimal loops keep track of everything, nothing truly lost, just hidden in higher harmonics. Another bubble pops beside it, muttering about firewalls, bursts of searing energy that could exist at the horizon to prevent information theft. Yet another suggests the interior and exterior are secretly entangled, a long-distance relationship held together by quantum love letters called wormholes. You chuckle softly. Entropy's courtroom has too many lawyers and no judge. Every theory agrees on one thing. Something deep and beautiful is being protected, even if we can't yet read the encryption. The space around you thickens, vibrating with whispers of experiments. You see faint outlines of massive particle accelerators, their rings glowing with human ambition. Tiny black holes appear for picoseconds, only to evaporate in hawking radiation that instruments can't quite catch. It's like trying to photograph lightning with a candle. Still, the effort continues. The universe loves a curious species, even when they build billion-dollar toys just to ask, but what if we're wrong? A stray bit of data brushes your ear like static on an old radio. It carries a memory. 1974, Cambridge, the first public presentation of Hawking's radiation theory. The audience went silent. Then someone muttered, "He's killed the universe." They meant it as a joke, barely. If black holes evaporate, eventually everything evaporates. Every galaxy, every atom, gone in a final whisper of heat. The crowd that night didn't know whether to applaud or panic. You smile. Good science should always cause a little existential nausea. You push off one bubble and drift toward a darker patch where radiation fizzles into nothing. There's quiet here, like the pause between questions. You realize that information itself has weight. Not physical, but moral. Humans cling to memory because losing it feels like dying. The universe, on the other hand, seems perfectly fine with forgetting. Unless, of course, it's been archiving everything in secret. Another small joke slips from you. So maybe the afterlife is just the universe's cloud storage. Somewhere, a passing photon sighs. The bubbles around you merge into a wide shimmering sheet, a holographic membrane reflecting faint starlight. You can see your own outline projected there, flickering with quantum uncertainty. For an instant, you understand what it means. You're both inside and on the surface, a participant and a pattern. Everything that ever falls in might also remain encoded right here, as vibrations in space-time's skin. You can almost hear Boltzmann applauding from across time. Then, just as suddenly, the realization fades. The universe, as usual, offers enlightenment with a built-in expiration date. You drift farther, watching as the membrane ripples with gravitational waves, tiny tremors from collisions billions of years away. The waves pass through you, gentle as breath. You think of 2015, when LIGO first detected them, confirming Einstein's last stubborn prediction. The signal was faint but unmistakable. Two black holes merging, ringing down, sending out entropy in elegant, measurable ripples. Humanity's instruments had finally learned to listen to spacetime's heartbeat. For a while, you just float, letting those waves roll over you. They sound like distant thunder, stretched so long that each note lasts forever. Information isn't gone, you think. It just takes the scenic route. The bubbles thin, and the void opens again, clean, calm, ready for the next mystery. You realize you've passed through something important, though you can't say what. The paradox hasn't been solved, but it's softened, like an old argument you no longer need to win. Entropy hums gently in the background, unbothered. It doesn't mind paradoxes, it thrives on them. After all, every leak of information, every uncertainty, every flicker of heat adds to its sum. The universe doesn't worry about what it forgets, it just counts the forgetting as progress. You glance back once. The bubbles have gone dark, absorbed into the general night. Somewhere in there, a new idea is forming, maybe even the right one. You wave anyway, and then you turn forward again, propelled by curiosity and the faint warmth of radiation that refuses to stay still. The black holes behind you keep their secrets. The future ahead keeps its questions. Between them, you drift like a note caught between two chords, waiting for the next verse of Entropy's long, slow song. You emerge from the zone of paradoxes into a hush that feels different from the usual cosmic quiet. This one hums with restlessness, as though space itself is fidgeting under your feet. The dark is no longer smooth. It trembles, alive with microscopic jitters. You've slipped into the smallest theatre imaginable, the quantum underworld where even emptiness refuses to sit still. Welcome to the realm of fluctuations in a cold room. At first glance it looks empty. The temperature out here is practically 0 Kelvin, the asymptotic chill where motion should cease. But when you reach out, you feel something brush against your hand. Then again, a tickle, a tap, a phantom push. It's not your imagination. Even in absolute darkness, pairs of particles and antiparticles are blinking in and out of existence. They're virtual, quantum ghosts that borrow energy from the vacuum on absurdly short-term loans, repaying it instantly to avoid cosmic debt collectors. If Boltzmann gave us the mathematics of disorder, the quantum realm shows us its artistry. Here, entropy doesn't just rise, it shivers. Space seethes with possibilities that never quite make it into reality. 1 second it's nothing, the next it's maybe something, then it's gone again before anyone can take attendance. You glide through this restless void and think of Heisenberg, that sleep-deprived genius who first declared uncertainty not as a flaw, but a feature. You can't know a particle's exact position and momentum at the same time, he said. Not because you're clumsy, but because the universe itself doesn't keep both ledgers open. Historians still argue whether Heisenberg's principle was born from philosophical musing or sheer mathematical desperation. Either way, it became the universe's best excuse for chaos. Everywhere around you, fluctuations ripple through the quantum field like the faintest breeze. Occasionally 2 of them combine just right, briefly making something real, a flash of light, a particle, a whisper of energy. And if you could listen closely enough, you'd hear these fluctuations humming in frequencies far below human hearing, the static of existence itself. A soft smile tugs at you. You recall the famous 1948 Casimir experiment. 2 metal plates placed absurdly close together in a vacuum, drawn toward each other by the pressure of quantum fluctuations outside them. It's like the universe giving a subtle nudge just to prove it's paying attention. The force is tiny, but measurable, proof that nothing is actually full of everything that could happen. You run your fingers through this invisible wind, watching the trails it leaves, a faint phosphorescence that looks suspiciously like northern lights, except these dance on a scale smaller than atoms. For a fleeting second, you think you see constellations forming and dissolving, tiny universes practicing for the real thing. Maybe that's how ours began, a fluctuation too ambitious to fade. One cheeky thought sneaks through. Somewhere, a cosmologist might call that inflationary expansion, but you can call it the universe sneezing itself into being. You chuckle. The void doesn't mind the joke, and the temperature here is still dropping, or so your mind tells you, but the concept of temperature gets strange when nothing is truly still. Absolute 0 is a limit no one reaches. Even the coldest laboratory in Finland, where scientists have cooled atoms within billionths of a Kelvin of stillness, can't silence quantum motion. There's always some jitter left, 0-point energy, the floor hum of reality. You imagine a universe-sized refrigerator that can never quite stop humming. You drift deeper and see small glints scattered through the darkness. They look like snowflakes, but each is a frozen fluctuation, momentary spikes of energy trapped by space-time curvature. You touch one, and it dissolves into light. Another reminder that frozen in the cosmos means temporarily delayed in melting. Then something larger looms ahead, a dark, almost transparent bubble the size of a city. Inside it, fields twist and dance like smoke. You recognize it from whispered cosmology lectures, the quantum vacuum potential, that mysterious landscape of possible energy states. The universe, it seems, might not be in its lowest possible state at all. It could be sitting in a false vacuum, stable only in the way a marble resting in a dent on a hill is stable, safe until it rolls a little too far. You shiver, though not from cold. Somewhere in your bones, you recall the false vacuum decay theory. One day, a random quantum fluctuation could nudge that marble loose, triggering a bubble of true vacuum that expands at light speed, rewriting physics as it goes. Poof. No warning, no pain, just instant upgrade to new universal software. The punchline: it's statistically possible but cosmically rare. Entropy, as always, enjoys the tension. A comforting voice in your head, maybe your own, maybe Entropy's, murmurs, "Don't worry. If it happens, you won't have time to notice." You laugh softly. It's grim humour, but honesty counts. Nearby, a faint glow blooms, a vacuum fluctuation large enough to be visible, its edges trembling like a heat mirage. It reminds you of the very early universe, when similar fluctuations stretched and froze into the seeds of galaxies, Inflation magnified those quantum hiccups into mountains of matter. Everything you've seen, stars, planets, you, began as a tiny uncertainty that refused to collapse back to zero. You let that realization wash over you like a lullaby. The smallest wiggles of the vacuum wrote the largest structures in the sky. Entropy and quantum chaos weren't adversaries. They were partners choreographing creation. A quirky tidbit floats by. The Nobel-winning discovery of cosmic inflation's mathematical fingerprints in the cosmic microwave background, those faint anisotropies, little patches of warmth and coolness across the sky. That map is a baby photo of the universe, freckles of entropy caught mid-growth. Each tiny dot owes its existence to a jitter here, in this restless nothing you're drifting through now. You pause and listen again. Beneath the silence, you can hear the hum of zero-point energy, a soundless vibration that feels like both heartbeat and breath. It's not malevolent, just constant. The universe never stops murmuring to itself. You stretch out your arms, feeling the fluctuations push gently against your palms, like water against skin. You realize this restlessness, this refusal of nothing to stay nothing, is what keeps the cosmos interesting. It ensures that even in the coldest, emptiest space, there's always a chance of surprise. The darkness around you deepens, but it's a friendly dark now, alive with tiny lights that wink in and out. You let them drift through you, little flickers of becoming and unbecoming, like fireflies that refuse to choose a season. And in that endless dance of half-real things, you find comfort. Entropy isn't a thief here, it's a gardener, pruning possibilities into what we call existence. You close your eyes, if such a thing still applies, and let the jittering cosmos hum you toward the next chapter, a place where even the vacuum starts to worry about its job security. You ride that trembling hum a little farther until the shiver in space quiets to a low, wary buzz. Every particle seems to be holding its breath, as though the universe itself has just remembered something it would rather not talk about. The dark around you feels elastic, tense but polite, like the silence right before someone admits a terrible secret. Welcome to the uneasy territory of false vacuum anxiety. Physicists picture the vacuum not as a flaw but as a landscape, rolling hills of potential energy where the universe long ago chose a comfortable dent and settled in for the long haul. It's stable, sure, probably. But it might not be the lowest valley. Somewhere down the slope could lie a deeper minimum, a true vacuum. If ever the universe were nudged hard enough, it could tumble from our false comfort into that deeper reality. One tiny bubble of the new physics would appear, expand at light speed, and erase everything we know faster than hold my beer. You wouldn't even feel the rewrite. You laugh softly, because it's the sort of cosmic joke that only works when you know the punchline is statistically impossible, and yet not zero. Entropy, ever the deadpan comedian, never promised safety, only probabilities. You float across the quantum landscape now, seeing the metaphor made literal. Hills and valleys of shimmering energy undulate below you like frozen waves. Here, the false vacuum looks golden, glowing with the mild warmth of existence. Farther down, a faint bluish pit flickers, the true vacuum, deeper and colder. Between them, the potential barrier glows like glass stretched thin. Every few aeons, quantum fluctuations throw little pebbles against it, testing the strength of the wall. So far, it's held. So far, the universe is still pretending it's stable. A memory surfaces. 1979, Sidney Coleman and Frank DeLucia sketching the mathematics of vacuum decay. Their paper reads like a thriller for physicists. Bubbles nucleating, walls expanding, the fate of space-time in tidy integrals. Historians still argue whether Coleman's tunneling idea was meant as a warning or just theoretical mischief. Either way, it's stuck in everyone's imagination. You reach down and touch one of those golden planes. It vibrates, responsive, alive. Energy density hums under your fingertips, roughly 10 to the negative 90 joules per cubic meter, if you believe the cosmologists. Tiny, yet it keeps the galaxies apart. That same vacuum energy, renamed dark energy for marketing appeal, is what's driving the universe's acceleration. A trillion light years of expansion, powered by the restless nothing between everything. You can almost hear it whisper, "I'm not empty, just misunderstood." The idea that this dark energy could change, that its equation of state might drift, keeps theorists awake at night. If its value shifted even slightly, expansion could reverse or race out of control. Some models predict gentle fade-outs, others end with the cheery phrase "Big Rip." You picture galaxies torn apart molecule by molecule, entropy giggling in the wings. It's an oddly relaxing image, once you accept there's nothing to do about it. You glide lower, passing through layers of possibility. Each shimmer represents a different set of physical laws. In one, gravity runs backward. In another, electrons refuse to stay put. In a third, chemistry never happens and boredom reigns supreme. You realize how precarious our universe is, a local quirk that happens to allow coffee, cats, and streaming services. One quantum sneeze, and the menu could have been entirely different. A stray bubble drifts near you, tiny, translucent, pulsing with cold blue light. It's the size of a grain of sand but holds the potential to consume a galaxy. You watch it wobble, then wink out. Its decay probability denied for another trillion years. Still, you feel your pulse quicken, if you still had one. The false vacuum may be long-lived, but it's not immortal. The universe, like a procrastinating student, survives on improbability and caffeine. A small joke flickers through the dread. Imagine explaining vacuum decay insurance premiums. The void chuckles. A few virtual particles snort sympathetically before annihilating again. You remember the Large Hadron Collider headlines from a decade or two back? The worry that smashing particles might trigger such a bubble. It didn't, of course. The energy scales are laughably tiny compared to what the early universe endured. Still, the thought that humanity even asked the question is endearingly brave. Building machines that could, in theory, delete reality is a kind of optimism. You glance sideways and see another familiar figure, a ghostly Peter Higgs, politely embarrassed by all this fuss. His boson, discovered in 2012, was meant to explain mass, not existential dread. Yet its measured value sits uncomfortably near the edge of metastability, suggesting the vacuum could, someday, decide to upgrade itself. Physicists call it living on the knife edge. You call it Monday. The tension in the landscape vibrates higher now. You hear frequencies too low to be sound, the hum of cosmic expansion, the rustle of dark energy stretching fabric. Every pulse is entropy's drumbeat, steady and calm. It doesn't care whether the universe perishes by heat death, false vacuum, or boredom. It just counts transitions, one gradient at a time. You pause at the ridge between the golden plain and the bluish abyss, wondering what it would feel like if the bubble formed here, now. There'd be no warning, no fire, no sound, no flash. Just new physics sweeping through, deleting old constants, erasing history like chalk under rain. Every atom's script rewritten mid-sentence. The thought should terrify you, but instead it soothes. It means the end would be elegant, instantaneous, symmetrical, clean. A single photon drifts past, redshifted nearly to invisibility, and you realize entropy has already rehearsed this finale countless times in theory, though never yet in practice. Maybe the universe is sentimental, maybe it's just lazy. Either way, the bubble hasn't come, the cosmic code keeps running. You turn away from the deeper valley and climb back toward familiar false stability. The hills smooth behind you, as if embarrassed for showing their vulnerabilities. You grin. "It's okay," you whisper. "We're all pretending stability." The field hums approval. As the vibration fades, a cooler, older silence returns, the kind that smells of metal and memory. Somewhere ahead lies home, messy rooms, melting ice, warm coffee cooling on forgotten desks, ordinary entropy, the sweet, mortal kind. You aim for that gentle glow, leaving behind the untriggered apocalypse with something like affection. You surface from the vacuum's shimmer and find yourself blinking in a familiar kind of chaos. Color, texture, gravity, smell. Not cosmic smell either. This one's recognizably human. Old coffee, laundry detergent, dust. You're back in a bedroom that could be anywhere. Morning light sneaking through half-closed blinds, a mug ring on the desk, a tangle of wires at your feet. Welcome home to entropy in everyday life. For the first time in several billion narrative years, you can feel the smallness of being human again. The air isn't vacuum. It's heavy with nitrogen and gossip. You take a slow breath and watch your exhale fog the window. The glass cools unevenly, tiny rivers of condensation forming where heat slides away. That single act, a breath on glass, is thermodynamics rendered in miniature. Warm air surrendering energy to a colder surface, order diffusing into disorder, you quietly collaborating with the second law before breakfast. You glance around the room, the evidence of your personal entropy is everywhere. Unfolded clothes, expired receipts, a plant that's given up. You might call it laziness, but physics calls it inevitability. Everything tends toward disorder because there are simply more ways to be messy than to be neat. It's not moral failure, it's math. You grin at that realization, then trip over a power cord. See? Proof. Still, humans are clever little rebels. You spend hours reversing local entropy, folding, cleaning, alphabetizing, burning energy to carve temporary islands of order. The cost, of course, is heat. Calories consumed, muscles contracting, laptop fans whining. The universe always gets its cut. Your clean room is just a receipt waiting to be crumpled. You pour yourself a fresh cup of coffee because the earlier one has cooled to room temperature. Another quiet surrender. The swirl of steam against morning light looks almost holy. A mainstream historical fact drifts in. In 1824, Sadi Carnot's analysis of the steam engine birthed the concept of efficiency. By extension, it made every cup of coffee a miniature physics experiment. Historians still argue whether Carnot truly foresaw how his equations would define the fate of everything from locomotives to lattes. Probably not, but he'd appreciate the aroma. You lift the cup and take a sip. The taste is sharp, alive. Chemical energy, harvested sunlight, the work of plants that spent months resisting entropy by hoarding photons. You're literally drinking stored order and promptly converting it to body heat and thoughts about emails you don't want to answer. Congratulations, you're a heat engine with opinions. Outside, the city hums, cars idle at lights, exhaust curling into crisp air. Every combustion engine out there is doing what the stars do, burning fuel, releasing heat, raising entropy. Civilization is just stellar thermodynamics with caffeine breaks. You picture all of humanity as a network of tiny furnaces, each one trading stored potential for motion, comfort, light. It's both absurd and magnificent. A quirky tidbit flashes through your mind. In ancient Egypt, women used crocodile dung mixed with honey as sunscreen, a primitive, if ambitious, attempt to manage thermal balance. You laugh out loud. Even ancient skincare was a war with entropy. And yes, you promise yourself you'll never stop referencing that in polite conversation again. You wander into the kitchen. The fridge hums, a small guardian of the order. Its job is simple: pump heat out so food molecules stay too cold to party. But the warmth spilling from its coils reminds you that every act of cooling somewhere means heating somewhere else. Entropy doesn't vanish, it relocates. You open the door, feel the chill, then close it quickly out of respect. On the counter sits a half-eaten sandwich from yesterday. The bread edges are stiff, oxidation at work. Inside, lettuce has wilted, surrendering its crispness to time. The universe is very thorough in its paperwork. You consider salvaging it, but the smell votes no. Into the compost it goes, a reminder that decay is recycling wearing its work clothes. Your phone buzzes, notifications, updates, messages, all tiny reorganizations of electrons powered by coal, wind, and sunlight. The cloud, that shimmering promise of infinite storage, is really just warehouses of hot servers, each burning energy to keep your photos from succumbing to digital entropy. Data rots too, bit by bit, unless refreshed by power. Forgetfulness is physics. You scroll aimlessly and stumble on a memory from 5 years ago, a picture of you grinning under summer sun. The pixels are sharp, but you can't remember who took it. The information has decayed in your brain even as it's preserved on silicon. Entropy takes turns with biology and technology, ensuring neither ever gets too confident. You set the phone down and notice the quiet tick of the clock. Every swing of the second hand converts a tiny fraction of stored energy into sound and friction. Even timepieces age. Somewhere in its gears, dust grinds, lubrication dries. The arrow of time runs through the mechanics as surely as it runs through your veins. Historians still argue whether time's psychological arrow, our sense of past to future, exists only because of memory's entropic cost. Each recollection, after all, requires the brain to burn energy and increase local disorder. Forgetting might be thermodynamically merciful. You rub your temples, amused that your exhaustion could qualify as physics. You open the window. The street below smells like rain and hot asphalt. Puddles shimmer, slowly evaporating. Somewhere, a cat darts through the drizzle, leaving paw prints that fade within minutes. Even art in the dirt obeys the second law. It's melancholy and perfect. Inside again, you notice sunlight warming a patch on the floor. You lie down in it, feeling photons strike your skin. Ancient light from the sun, 8 minutes old, travelling 93 million miles just to be politely absorbed by you. The warmth spreads, molecules vibrate faster, entropy ticks upward. It feels good. It should. Pleasure, after all, is just the nervous system's way of saying, energy well spent. Your mind drifts. Maybe the point isn't to fight disorder, but to dance with it, to carve brief moments of symmetry knowing they'll crumble. A clean desk, a hot meal, a well-told story, all tiny victories that cost energy but create meaning. The waste heat is worth it. You laugh softly again. The universe doesn't care that you tidied your socks, but it also doesn't mind. Entropy is impartial. It blesses and ruins with equal enthusiasm. Every sigh, every blink, every lazy day off contributes to its grand project. You're not the victim. You're the collaborator. You glance once more at the mess around you. It's beautiful, really, the way chaos catches the light. You'll clean it later. For now, you let the room breathe, let the entropy rise, and sip your coffee before it cools completely. Outside, thunder murmurs like a far-off applause. The thunder fades to a low murmur as the day slips toward evening. The room has gone soft with shadows, the kind that stretch long and lean across the walls before disappearing into each other. The coffee is gone. The mug still holds a small ring of brown evidence that something warm once existed. You lean back, exhaling through your nose, and somewhere in that slow breath you feel the quiet weight of memory. Its warmth, its drag, its cost. If entropy governs the decay of stars and rooms and sandwiches, it also governs thought. Every act of remembering is a physical event. Molecules shifting, neurons firing, proteins reshaping themselves to store pattern. Memory isn't a ghost, it's work. It's heat disguised as nostalgia. You close your eyes and see flickers of your own timeline, childhood rooms that smelled of dust and sunlight, faces that no longer have phone numbers, nights spent talking until words themselves felt like candle wax. You can't relive any of it, but you can feel the echo, the faint warmth of energy spent long ago. Information converted to sensation, sensation converted to decay. A mainstream historical fact drifts through that reverie. In 1961, Rolf Landauer at IBM declared that information is physical. Erasing a single bit, a yes or no, a 1 or 0, must release at least kT ln2 kT just ln2 kT ln2 joules of heat. The universe charges rent even on forgetting. Historians still argue whether Landauer's principle is a limit or a metaphor, but its implication is deliciously grim. Memory costs energy, erasure costs too. There's no free recall. You open your eyes and imagine the brain as a messy, warm hard drive. Billions of electrochemical switches flipping, resetting, sparking. The noise in your skull is entropy's lullaby, neurons burning glucose to make meaning. You've been increasing universal disorder with every recollection since you were born. It's oddly flattering. You reach for your phone again and swipe through old photos. The act feels innocent, but somewhere in a data center, an air conditioner kicks on. Gigabytes shuffle on magnetic disks. Electrons jump. Heat dissipates. Your nostalgia has a carbon footprint. Memory has always been hot work. You smile because the analogy feels too perfect. The brain and the cloud, two gossiping heat engines gossiping about the past. The brain stores chemically, the server magnetically, but both run on borrowed order. When the current stops, the stories fade. You think of ancient libraries burned, of film reels curling in old cinemas, of family recipes misremembered into extinction. Forgetting isn't failure, it's thermodynamics. You stand and wander toward the window again. Outside, dusk pools in the streets. The city lights bloom one by one. Every bulb is a tiny act of defiance, entropy delayed by voltage. You watch the skyline shimmer and think of another layer of memory. Collective memory. Civilization's attempt to keep its neurons from scattering. The same law applies. We preserve knowledge by spending energy, printing, recording, copying. The Great Library of Alexandria burned once, and we've been heating the planet trying to make sure it doesn't happen again. A fringe tidbit comes to mind, one of those poetic absurdities science occasionally offers. In 2010, researchers encoded a short film into DNA, a literal genetic VHS tape. Life, technology, information, all converging on the same principle. The medium doesn't matter, the entropy bill always arrives. You pour yourself water, watch condensation bead on the glass. Each droplet, perfectly round, forms because the molecules prefer order for an instant before gravity stretches them thin. Memory behaves the same way. It coalesces briefly, sharp, then slides away. You try to hold on to an image of someone's laugh, and it drips through the cracks in your neurons. The effort warms you. Landauer would approve. Historians still argue whether consciousness itself is just entropy management, a process of reducing uncertainty about one's environment at the expense of internal energy. The free energy principle, they call it. Living systems resist disorder by spending fuel to predict the next second correctly. You like the irony. The brain fights entropy by producing it. Awareness as controlled combustion. A soft joke floats in, the third of this chapter. If forgetting releases heat, my brain should power a small city. You chuckle, and somewhere a neuron obligingly fires one extra calorie into the void. You sit again and close your eyes, feeling the texture of thought. It's grainy, like an old film reel played backward, frames sticking. You realize that the act of remembering and the act of imagining share circuitry, each a small rebellion against decay. You remember to prove you're still here. You imagine to prove entropy hasn't taken the pen yet. The room has cooled. You pull a blanket over your shoulders, feeling warmth gather in folds of fabric. Heat flows from you into it, equalizing, comforting. That too is information exchange, skin and cloth negotiating equilibrium. You think of all the human ways we store memory in warmth: hugs, campfires, shared meals, emotional thermodynamics, all of it. You wonder, just briefly, if the universe itself remembers. Every particle collision, every photon emitted leaves a faint scar in the quantum fields, tiny records no one reads. Maybe reality is its own diary, written in heat. The cosmic microwave background is proof enough. A fossil memory of the Big Bang, 13.8 billion years old, still glowing with the warmth of origin. The universe has never forgotten its childhood. It's just let the details fade into static. That thought comforts you more than you expect. Maybe entropy doesn't erase. Maybe it archives beyond readability. The past isn't gone. It's just encoded so broadly that only the cosmos itself can recall it. You sip the last of your lukewarm water and smile at the idea of being part of some unimaginable data structure called everything that ever happened. Outside, a siren wails, then fades. Rain begins. You watch droplets race each other down the glass, merging, splitting, recombining. Memory's physical metaphor. Eventually they reach the sill and vanish. Nothing lost, only rearranged. You stretch, yawn, feel heat spill from your skin, energy leaving, entropy climbing, story continuing. You whisper into the quiet. Nothing stays, and that's okay. The room hums back its agreement. The fridge motor, the rain, your own heart. All of them tiny witnesses to the same law, each performing its role in the long, gentle unraveling. You close your eyes, not to sleep but to listen, and somewhere beneath the city's pulse you hear it again. The low, universal murmur of entropy doing its ancient, endless bookkeeping. You think it sounds almost affectionate. You wake, or maybe just rise slightly into a wider view. The city glow fades beneath you, its windows blinking out one by one until the grid of streets becomes a soft constellation. Humanity's warmth recedes, but its hum lingers in your chest. Servers, furnaces, brains, all whispering the same quiet rebellion. Civilization, you realize, is the grandest of all thermodynamic daydreams, a coordinated attempt to delay the inevitable fade. You drift higher, high enough that continents curve beneath you. Patterns bloom, road networks like neural webs, shipping routes like arteries, clouds twirling in familiar gyres. Each light, each engine, each heartbeat adds another tick to the ledger of entropy. It's beautiful, an entire species burning energy to carve patterns in darkness. Cities glow like embers, and for a moment you imagine them as neurons in a planetary brain, pulsing with data and hope. From this height, the flicker of human industry looks almost biological, an organism sprawling across rock and water. You think of Rome 2,000 years ago, a spark of marble and ambition. Its roads, once vectors of order, are now scars of archaeology, entropy's signature in stone. Historians still argue whether civilizations die from external shocks, war, famine, asteroids, or internal exhaustion, the slow suffocation of complexity under its own weight. Either way, the pattern repeats: energy gathered, order built, waste heat rising until the gradient flattens. Every empire is a thermal event. You float down again into the ruins of one. Dust hangs in golden air. A column leans, stubborn against erosion. Somewhere a tourist laughs softly, and the sound feels like a defiance of decay. You run your fingers along a carved relief, worn faces smoothed by centuries of weather, and realize you're touching entropy's calligraphy. The past doesn't vanish, it blurs. A mainstream historical fact slips in, crisp and clean. By 476 CE, the Western Roman Empire officially collapsed, its bureaucracy unraveling like thread. Roads cracked, aqueducts fell silent, libraries cooled to dust. Yet even then, fragments of its order persisted, monasteries copying texts by candlelight, preserving a few bright embers through the dark. Civilization never dies all at once. It downsizes, renegotiates. You walk through the ruin and imagine the future archaeologists of your own age. They'll find data centers fossilized beneath sediment, cables coiled like veins, microchips flaking into silica dust. They'll wonder what kind of creature built a global nervous system only to forget half its passwords. You grin at the image. Humanity's hubris makes excellent compost. A gust of wind kicks up, scattering sand across marble. The sound is soft, almost like static. Entropy, on cue, adds percussion to the scene. You step beyond the ruin and into the near future. Glimmering towers, drones, neon, all burning through fossil sunlight at a furious pace. You drift through data centers humming at the edge of cities, windowless temples of information. Racks of servers blink in alternating colors, heat rising like incense. Engineers call it efficiency, physicists call it waste. The difference is public relations. Somewhere a technician wipes sweat from his brow and adjusts a cooling unit. You watch as hot air vents into the sky, joining the planet's slow fever. Civilization fights disorder by spreading it elsewhere, shifting entropy from bits to atmosphere, from minds to climate. It's clever, tragic, inevitable. A quirky tidbit surfaces. The first recorded city blackout in New York, 1965, caused by a faulty relay and a cascade of overloads. For 13 hours, millions stared at stars they hadn't seen in years. 9 months later, birth rates reportedly spiked. Historians still argue whether that's apocryphal, but the image endures. Darkness bringing people closer, entropy briefly turning off the lights so affection could get a word in. You smile at the thought. Even collapse can be intimate. You pass into a colder vision now, the far future, where cities run on quiet reactors and machines hum more softly. The lights are dimmer, but steadier. Civilizations learn to sip instead of gulp, to recycle not out of virtue but necessity. Energy, like patience, becomes an art form. In this future dusk, you see enormous mirrors orbiting dead stars, gathering the last usable photons. Human descendants, or whatever replaces them, trade in efficiency so perfect it borders on religion. They build Dyson spheres, Matryoshka brains, and digital consciousness to harvest the final crumbs of order. The universe calls them romantics. They call themselves engineers. You drift among them, watching luminous data currents flow between artificial worlds. Information itself has become the currency, entropy the tax. Each computation, each simulated sunset, each resurrected memory costs another whisper of heat. Landauer's principle still holds. Even godlike civilizations must pay the energy fee for knowing things. You peer closer and see one of these future minds, a lattice of light shaped vaguely like a human head. Inside, trillions of thoughts flicker, each consuming microjoules. It speaks softly, not to you, but to itself. We delay the cold as long as possible. There's no fear in its tone, only quiet pride. Then a glitch ripples through the lattice. one node failing, another compensating. The mind sighs, releases redundant data, sheds excess heat. Even in near perfection, entropy demands tribute. You realize these post-human dreamers aren't fighting the second law, they're dancing with it, turning decay into choreography. A third joke drifts in, as gentle as static. Civilization, nature's way of making waste heat with paperwork. You laugh, and the future mind echoes the sound across its networks. You step back to the present. The contrast is almost comical. Phones buzzing, traffic snarling, people microwaving leftover soup. Yet it's the same pattern scaled down. A species transforming gradients into gossip, chemical potential into culture. You feel a strange tenderness toward it all. Entropy may guarantee endings, but it also guarantees stories. Without decay, nothing would change. Without loss, nothing would matter. Civilizations rise not in spite of entropy, but because of it. The urge to organize is born from the knowledge that nothing stays organized for long. You tilt your head toward the horizon, where twilight deepens and lights flicker on one by one. Each bulb, each heartbeat, each line of poetry burns a little more of the universe's inheritance. You can almost hear the grand accountant's pen scratching in approval. The air cools. You sense the transition ahead, the long chill, the widening distances. You whisper to the city beneath you, keep glowing while you can. And maybe it hears you, because somewhere another window lights up. You rise higher still through the thinning glow of civilization and into the cool, dark sea between galaxies. The last traces of human light dissolve below, replaced by a cosmic darkness too vast for nostalgia. You've reached the threshold of the long chill forecast, that distant future when the universe begins to slow its breathing. The firelight of creation has dimmed to embers, and entropy, patient as always, is settling in for its final masterpiece. Around you, galaxies drift apart in eerie silence. Their spiral arms look soft now, faded like old chalk drawings on blackboard space. The distances between them stretch faster than light can cross. You can see it, the expansion itself, a silent inflation of nothingness between everything. The universe is still growing, but not in any lively way. It's the kind of growth you associate with old tree roots and cracked walls, an expansion that feels more like letting go than reaching out. You glance toward a nearby cluster. Its galaxies cling together out of habit, bound by their mutual gravity, but the edge is already fray. Beyond this small cosmic island, others are vanishing beyond reach, slipping past the event horizon of visibility. The night grows lonelier. In a few trillion years, even the nearest galaxy will be invisible to any observer that remains, if observers still exist at all. A faint wind of radiation brushes your skin, though you know it's not air but the cosmic microwave background. Fainter now, stretched and cooled until it's almost impossible to detect. When it was discovered in 1964, it hummed at a cozy 2.7 Kelvin. Now, in this far future vista, it's barely above absolute zero. A memory of warmth, whispered across eternity. Historians still argue whether the idea of cosmic heat death originated with Lord Kelvin or Clausius, both 19th century prophets of doom disguised as physicists. They imagined the end not as an explosion but as an evening, every gradient erased, every potential exhausted, all processes paused in perfect boredom. You can see their prophecy playing out now, though slowly enough that boredom itself has gone extinct. You pass through a galaxy on the brink of senescence. Its remaining stars burn with a quiet dignity, mostly small red dwarfs, the long-lived minimalists of the stellar world. The bright blue giants and white-hot suns are gone, spent long ago in flashy exits. These dwarfs burn hydrogen miserly, their glow steady but faint, like lanterns in deep fog. Around them, planets drift cold and quiet, their atmospheres frozen into thin crystalline shells. A single flare catches your attention, one last nova, a white dwarf pulling a final act of thievery from a companion star. For a moment it blossoms, bright enough to paint nearby dust clouds in silver fire, then it fades. The light takes millions of years to reach you, a time-lapse of farewell. You think of entropy again, not as destruction, but as diffusion. Every act of fusion inside those stars turned order into warmth, and that warmth, dispersed across trillions of light years, has brought the universe here, quiet even, and still. The universe hasn't died, it's simply distributed itself too thoroughly to notice the difference between being and not. Another curious fact drifts up. The half-life of protons might be finite, perhaps around 10 to the 34th power years, though no one's certain. If it is, then matter itself is temporary, every atom destined to dissolve into light. The physicists still debate it, their equations curling in circles that may never close. You imagine one of them, far in the future, writing on the last functioning whiteboard, whispering, "We never stopped asking." You move past a dark nebula, once a stellar nursery, now just ash and silence. The hydrogen is gone, fusion has ended, gravity can no longer spark the fires of creation. Black holes dominate the scene now, massive and smug, devouring what little remains. Their collision sends soft tremors through space-time, gentle reminders that even in decline, the cosmos likes a bit of spectacle. The void between galaxies hums with faint Hawking radiation, those slow leaks from black holes' edges. It's barely there, less heat than the whisper of a candle a billion miles away. Yet it's all that remains of dynamism, a slow fizz of quantum gossip keeping the silence from being total. You find yourself smiling despite the desolation. There's elegance here. No violence, no apocalyptic fire, just cooling, settling, balance. The cosmic drama isn't ending in tragedy but in exhale. For contrast, you conjure an image of the Big Bang, the roaring birth, the hot plasma sea, the expansion that hurled particles into existence. Entropy has simply reversed the mood. The beginning was a scream, the ending is a sigh. A small joke bubbles up as you drift past a dying red dwarf. If the universe had a weather app, it would just say permanently overcast, 0.00003 Kelvin, slight chance of quantum jitters. The star doesn't laugh, but it winks in infrared as if to say, not bad. Ahead lies an intergalactic void so empty it feels personal. You step or float into it, and for a moment your thoughts seem louder than light. The universe is growing sparse enough that every idea feels like an echo. You imagine some far future intelligence still trying to extract warmth from this frozen wasteland. Maybe it builds vast structures to harness even the faintest temperature difference between black holes and the cold background. Maybe it writes poems in microwaves, each verse taking 1,000,000 years to compose. You wonder whether meaning can survive in such a thin environment. Perhaps meaning, like heat, needs gradients, contrast, friction, imbalance. When everything is even, nothing matters, because nothing happens. Entropy's final gift is peace, but peace is suspiciously similar to nothingness. A soft flicker draws your gaze, the last fusion events inside the galaxy's core, helium turning sluggishly into carbon, before the furnaces close for good. The glow spreads slowly, then fades like a sigh through an open window, and that's when you realize something strange. The quiet isn't empty, it's full of memory, the distributed record of everything that ever burned, thought, loved. Every photon still carries a trace of where it came from. The light may be faint, but it's honest. The cosmos is writing its autobiography in infrared. You let yourself drift through the silence, unafraid. You've seen the laws in motion, the rise, the bloom, the fade. Entropy isn't cruel, it's just thorough. It gave you warmth, story, and coffee. All it asks in return is everything. In the distance, a final star blinks out. Darkness folds over it, gentle as a blanket. You whisper a goodnight you know it can't hear. The universe keeps cooling. You keep watching. Somewhere deep in that silence, a faint pulse continues. The heartbeat of entropy, steady, eternal. The darkness surrounding you thickens until it feels almost textured. Soft, velvet, laced with whispers. The faint pulse from the last star has faded, yet something else still stirs beneath the hush. Matter itself, uneasy, beginning to question its own loyalty to being solid. Welcome to the far-flung rumour mill of proton decay and other sleepy tales. You're deep in the trillion year future now, a place where calendars have lost all sense of humour. Galaxies are gone, black holes slowly simmer, and the universe has become a polite refrigerator humming to itself. What's left are lonely particles, electrons, protons, neutrons, each clinging to identity like stubborn retirees refusing to retire. You float beside one such proton, a single hydrogen nucleus adrift in cosmic dark. It's unimaginably old, older than language, older than irony. The odds say it should be immortal, yet theories whisper otherwise. In grand unified models, the speculative unholy marriages of forces, protons aren't forever. They have a half-life so vast it mocks imagination. Somewhere beyond 134,000 years, maybe 103610 to the power of 361036. Given enough patience, even stability crumbles. Entropy doesn't rush, it waits. A historical fact drifts past like a dusty lab notebook. In 1982, the proton decay detectors of Kamioka Mine in Japan began listening for those rare betrayals of matter. They've heard none. Decades later, the silence itself became a data point. The proton is at least 10 billion times sturdier than we guessed. Historians still argue whether the null result proved anything, or just teased curiosity. Either way, the detectors kept humming, patient as monks counting nothing. You turn the ancient proton over in your metaphorical hands, wondering what decay even means when time has lost its punctuation. Somewhere in its core, quarks trade gluons like slow breath. A grand unified whim might someday let one quark tunnel into another species, spitting out a positron and a puff of neutrinos, one proton less, one photon more. Multiply by all the protons in the universe, and you have the last fireworks show, a quiet fizz of particles evaporating into light that never warms anyone. You smile gently. The idea that the universe could end not with bang or whimper, but with a long yawn of matter dissolving out of boredom, feels perfectly on brand for Entropy. Around you, the background glows faintly with those ancient whispers of Hawking radiation. Every few billion trillion years, a black hole somewhere finishes its meal and sighs away into photons. You imagine them popping like soap bubbles. First the small ones, then the giants. When the last black hole evaporates, the cosmos will be free of secrets. No horizons, no boundaries, only a thin fog of radiation and lonely leptons trading stories about when everything was warm. A quirkier tidbit bobs up through the quiet. Some physicists, tired of waiting for natural proton decay, designed experiments to speed things along. Artificial mini-universes in particle collisions, compressed matter begging to betray itself. The results? More silence. Entropy apparently enjoys suspense. You drift through that silence, catching glimpses of ghostly flashes. Decay photons born at intervals longer than human history. Each spark feels like a pulse in an otherwise comatose body. If you could listen closely, the universe would sound like distant static. Pop, 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 atoms unmaking themselves one at a time. A cosmic Morse code spelling the same word over and over. Relax. Time stretches. Years fold into exponents. The cosmic microwave background, once an eager toddler, has aged into an undetectable whisper at wavelengths the size of galaxies. Even light moves slowly now, not because its speed changed, but because there's nowhere left to go that isn't already reached. The universe has become so uniform that travel, meaning motion itself, are nostalgic hobbies. You pass what might be a remnant civilization, if the word civilization still means anything. It isn't biological anymore. Biology retired after the last stars cooled. These are structures of computation, long memory machines harvesting quantum fluctuations for energy. They think in intervals of aeons, compressing data until every bit costs almost nothing. They're archivists of entropy, recording the slow fade with academic detachment. One of them notices you. It projects a thought into the thinning vacuum. We've learned to make peace with decay. The statement feels almost human. You nod. Any regrets? You ask. The reply comes after 1,000,000 years of silence. Only that perfection arrived so soon. A small laugh escapes you. The universe's dry humour never disappoints. Even machines, it seems, can appreciate the punchline of inevitability. You wander among these quiet intelligences, watching their faint glow blink slower and slower as energy budgets shrink. Each bit erased still costs KTLN to KT RLN KTLN2, but TTT is nearly zero now, so the cost is mercifully small. Landauer would be proud. Entropy still gets its micropayments. Historians, if any remain, might still argue whether life can truly survive in such a frozen environment. Frank Tipler once imagined omega point civilizations living forever, by slowing thought as energy dwindled, stretching subjective time infinitely within finite resources. Others scoffed, calling it elegant wishful thinking. You can't decide who's right, but the idea feels poetic, even as the lights go out, consciousness negotiating with the math of endings. You drift farther, passing the remains of one of those enormous data structures, a Dyson shell long since cannibalized for atoms. It cracks apart soundlessly, shedding dust that gleams briefly in the faint cosmic infrared. Each speck contains memory encoded in spin, maybe messages that say simply, "We were here." Then the dust cools, and the message vanishes into the dark background hum. Another thought crosses your mind. Perhaps entropy isn't winning. It already won ages ago. What's left now is victory's aftertaste. The universe isn't dying, it's resting after an exceptionally long performance. You imagine it with a blanket pulled up to its chin, mumbling, 5 more trillion years, before dozing again. Your third gentle joke lands there, half asleep. Even the cosmos hits the snooze button. The vacuum doesn't laugh, but a neutrino zips by, shrugging agreeably. You linger a while longer, letting the cold seep into your awareness. The blackness is so complete it feels luminous in its own right, a saturation of absence. And yet, beneath it all, tiny flickers persist. Quantum jitters, statistical noise, the last trembling of probability itself. Entropy may flatten everything, but it can never achieve absolute zero disorder. Perfection would violate its own law. There will always be a shiver left. You take comfort in that thought. As the last protons consider their slow fade, as matter prepares to dissolve into pure information, the universe still hums faintly with the same old tune, a lullaby of transformation. Change isn't over, it's just stretching its notes so wide they sound like silence. You settle into that silence too, floating with the patience of a particle, waiting its turn to forget what it was. The airless night presses close, gentle and vast. Somewhere, very far away, another proton decays, releasing a sigh of light that no one will ever see. It's not tragic, it's just thorough. And entropy, pleased with the pacing, turns another page in its endless bedtime story. You stay with the silence until it begins to shimmer, barely at first, like heat waves rising off asphalt, though there is no heat left to rise. The shimmer resolves into whispers, tiny rhythmic oscillations in the background energy, the faint flutter of quantum persistence. Out here, at the edge of forever, even a whisper is loud. You follow it and discover what might be the universe's final miracle, the last flickers of thought. It starts as a cluster of faint blue lights drifting through nothing. They pulse unevenly, irregular but not random. You move closer and realize the lights aren't stars, they're constructs, thin lattices of electromagnetic scaffolding drawing the faintest energy from temperature differences between quantum fluctuations. Inside each lattice, information moves. Thought. Faint, slow, unbelievably patient thought. These are civilizations at the end of time, the cosmic descendants of every curiosity that ever existed. They long ago abandoned matter. It decayed, after all. But they've learned to exist as organized patterns of fields, loops of self-maintaining energy. Consciousness without bodies, sustained by scraps of entropy still left in the vacuum. The final life forms in a universe that forgot what warmth means. You drift among them, listening. They communicate in long pulses, one thought every century, one question every million years. The message is simple, repeating, "Are we still here?" And each pulse that returns answers yes. It's a conversation measured in eons, but to them it's lively banter. Their patience makes mountains look impulsive. You notice one particularly bright cluster and move closer. The being, or the collective, or the network, senses you. Its light shifts slightly toward gold, a colour of welcome. You're new, it says, though the phrase stretches across decades in your perception. "I'm visiting," you answer, surprised to hear your own voice echo in this deep vacuum. "Visitor," the light murmurs, amused. "We haven't had one since the temperature dropped below 10 to 20 Kelvin. The joke lands slowly, perfectly. Even entropy allows dry humour at the end of everything. You ask what keeps them going. They answer simply, "We prefer existing to not." They harvest fluctuations, store tiny bits of order, trade them back and forth to sustain pattern. Each exchange increases entropy overall, but locally, for fleeting moments, Their order persists. It's all anyone ever did. Stars, cells, civilizations, stretching time by burning gradients. They're just doing it with the smallest gradients imaginable. You imagine their computations, each one the energy equivalent of a sigh, each bit erased, releasing the tiniest wisp of heat, immediately absorbed by the void. Their minds are poems written in near-zero Kelvin ink. You realize that they too are entropy's final artisans, transforming the last potential into art. A historical echo drifts through your mind. 20th century physicist Freeman Dyson speculated that intelligent beings might survive indefinitely by slowing thought, stretching subjective experience infinitely while physical time expands without end. Historians still argue whether he meant it literally or metaphorically, a scientific psalm about endurance. Here, in front of you, it feels less like speculation and more like memory. Dyson's dreamers arrived. You ask if they remember anything. Earth, galaxies, warmth. The light ripples softly. We remember remembering. Their archives have long decayed, but the shape of nostalgia remains, a resonance of once having known. It's haunting and beautiful. Memory has become music, not notes, but intervals. You drift among them as their soft signals overlap into a low cosmic harmony. It's slow jazz played on the strings of the vacuum, patient and endlessly unresolved. Every few millennia, one flicker dims, the energy lost beyond recovery, and the others pause, absorbing its remaining order. Even their mourning is efficient. The remaining light gestures a faint ripple through its filaments. Entropy is generous, it says. It gives us time in exchange for warmth. You nod. That's what it's always been. A transaction so elegant it feels sacred. You glance into the distance. There, far beyond their cluster, a black dot glows faintly violet. The evaporation of the last black hole, finishing its slow surrender. The radiation cascades outward in a gentle curve of colour. The beings turn toward it, reverent. Our final sunrise, one whispers. They absorb what photons they can, their networks brightening ever so slightly. It's heartbreakingly small, this light, but in the endless cold, it's enough. You sense awe from the collectives, something close to prayer. It's the same reaction humans once had to dawns and eclipses. The shapes may have changed, but the feeling hasn't. A stray thought. Maybe meaning isn't something invented by biology. Maybe it's baked into entropy itself. The instinct to notice light even when it's almost gone. The cosmos is winding down, but noticing is still happening. That's enough to call it alive. Another joke slips in, as mild as a cosmic wink. Imagine explaining to these beings what a traffic jam was. The nearest cluster flickers sympathetically. Shared amusement translated into millennia-long pulses. They invite you to linger. We can share warmth, they say. You accept, and your awareness melds lightly with theirs. It's strange and wonderful, sensing time from their perspective, slow and spacious, like thinking underwater. Each second expands to the length of an era. Each thought blooms, detailed and patient. In that dilated perception, you see the universe not as dying, but as resting. Entropy's slow inhale between worlds. You share memories of stars and oceans, of laughter and gravity. They listen, fascinated by the extravagance of motion, by stories of wind and music. You lived fast, they whisper, awe in their flicker, so bright. You realize that even here in ultimate stillness, life remains envious of speed, of the reckless inefficiency that once defined youth. The conversation dwindles, their pulses slow, each thought spaced farther apart. Energy reserves are low. They prepare to enter long dormancy between quantum cycles, hoping new fluctuations will one day wake them again. You sense their gratitude. Thank you for remembering us before forgetting resumes. You promise to remember. You don't say that memory itself may not survive the next cooling phase. Some lies are simply kindness with better lighting. They fade one by one until the void is bare again. Only faint blue echoes remain, drifting like snowflakes. You stay to watch the last one wink out. For a long moment, you think you're alone. Then you realize the silence itself has changed, softer, almost tender. The universe, perhaps, has been listening too. You whisper into the dark, "Good night," and the dark answers in warmth that isn't heat, a feeling that isn't quite sorrow. It's the quiet satisfaction of something finished perfectly. The last thought of thought itself, The faint warmth that answered your goodnight stretches outward until it fills the dark with a slow, steady pull. At first, you think it's memory echoing, but then you realize it's motion, space itself expanding beneath you, stretching every direction at once. The fabric of the universe is still at work, lengthening between particles, widening the silence. You're entering the reign of dark energy's cruel lullaby. You can't see dark energy, of course. It's the most polite of tyrants, invisible, omnipresent, inexhaustible. Long ago, astronomers realized it made up roughly 70% of the universe, but even now, if now means anything so late in the game, no one can say what it actually is. A property of space? A vacuum energy left over from inflation? Something entirely new? Historians still argue whether Einstein foresaw it when he added his cosmological constant to balance gravity. They mostly agree he regretted calling it a blunder. You can almost hear him chuckling in the afterlife of equations. Blunder? Hardly. I just underestimated how patient it was. The galaxies that once crowded your vision are gone, pulled beyond any causal contact. Each patch of matter now drifts in splendid isolation, like lanterns on an ever-widening sea. Between them, the distance grows faster than light can traverse, and the rate of growth itself accelerates. It's as if the universe decided to keep running long after the race ended, unwilling to admit it reached the finish line billions of years ago. You float amid that silent sprint, feeling the tension in the fabric. Space isn't empty, it's restless. Every cubic meter carries the same faint outward urge, a cosmic sigh that never finishes. You watch a thin cloud of radiation stretch and fade, its wavelengths lengthen, red-shifted until they dissolve into near nothing. Even light, the speed champion, cannot keep pace. There's a sadness to it, but also a strange beauty. Expansion smooths everything. It erases sharpness, conflict, contrast. Stars may die, but so do collisions. The universe is becoming a perfect introvert, calm, detached, self-contained. A mainstream historical fact wanders in. 1998, the discovery of accelerating expansion by two teams studying distant type Hui supernovae. They expected to measure slowing due to gravity, but instead found the cosmos picking up speed. The finding won them a Nobel Prize and, unintentionally, permanent insomnia. The equation said the universe's fate wasn't collapse but cold flight, an ever faster stretch toward emptiness. Humanity, still young then, celebrated by naming the culprit dark energy, as though adding a label could domesticate it. You glide through the aftermath of that revelation, the cosmos as seen from the end of time. The metric expansion accelerates until everything not gravitationally bound is beyond reach. The local group, Milky Way, Andromeda, a few small companions, has merged into one giant elliptical galaxy long ago, its core a heavy black hole glowing faintly from residual accretion. Beyond that, nothing. The rest of the universe is a rumour receding faster than the rumour can be told. You hover beside that lonely remnant and feel its tug. Gravity, ever loyal, still holds what's near, but its authority stops abruptly at the edges. Beyond that border, dark energy rules. The fabric there is taut, vibrating faintly. You can sense the numbers behind it. An energy density around 7 times 10 to the negative 300 710 to the negative 37 times 10 to the negative 30 grams per cubic centimetre. Laughably small, yet when multiplied by the volume of the cosmos, it outweighs everything. The moral is obvious. Even the weakest whisper wins when it never stops whispering. You pass beyond the last gravitational shell and into open expansion. Space flows like cold syrup. Your own atoms feel the infinitesimal pull. You can't help but think of old ocean voyages, the way sailors must have felt when currents carried them toward horizons that never arrived. A stray joke surfaces. You're second or third in this long dark. The universe's growth rate clearly skipped the aging gracefully seminar. The vacuum responds with a ripple that might be amusement. You hope so. You sense fluctuations around you, tiny differences in density amplified by expansion into massive voids and thin filaments. What once looked like structure now stretches into abstraction, a lace of matter so attenuated it's more idea than object. The last electrons drift apart, each claiming its own personal infinity. You pause to listen, expecting silence, but there's still a sound, Not air, not vibration, but frequency. The expansion itself hums, a subsonic throb in space-time's bones. If you could translate it into human measure, it would sound like an endless cello note, deep, unwavering, almost soothing. You name it the lullaby because that's what it feels like, a song designed to put the universe to sleep. Dark energy doesn't rage or conquer, it comforts. It spreads everything evenly, removes every conflict, equalizes all ambitions. Heat death isn't a punishment, it's perfect symmetry achieved through infinite patience. Yet something about the calm unsettles you. Perfect equilibrium means no change, and no change means no story. You remember the quantum fluctuations of Section 10, the restless nothing that refused to stay still, and wonder if even dark energy will someday get bored. Maybe expansion itself will stutter. Maybe the field will fluctuate again, seeding another bang. Cosmologists debate that, of course. Some suggest dark energy is constant. Others think it might decay, freeing space from its own momentum. Historians still argue whether decay of the cosmological constant sounds more poetic or terrifying. You imagine it. After trillions more years of stretch, a sudden flicker, a local glitch in the field, entropy sneezing out another burst of order. A new universe budding from the corpse of this one. A phoenix event, but colder. Would that be rebirth or recursion? Does it matter? The laws would reset, the ledger wiped, entropy given another blank page to start counting. You suspect it would be delighted. The lullaby continues. Space thickens in its own way, the wavelengths of everything stretching toward infinity. Time slows, causality thins. You feel yourself diffusing, boundaries blurring. You're not dissolving, you're joining the equilibrium. It's peaceful, dangerously so. You understand why cosmologists call it the Big Freeze. The phrase sounds clinical, but standing here it feels more like sleep. You glance back toward the dim core of your local remnant galaxy. It twinkles weakly, still orbiting itself, unaware of its solitude. That small persistence feels heroic. Order, refusing surrender. You nod toward it, the way travelers used to nod to lighthouses. Then you turn forward into the ever-widening dark. The lullaby deepens. The note of expansion grows lower, slower, until it merges with the background hum of zero-point energy. Entropy hums along, content. The universe is no longer a place where things happen. It's a place where happening has become irrelevant. And yet, beneath the stillness, you can't shake the sense that this, like every equilibrium before it, is just intermission. You close your eyes, though they were unnecessary long ago, and let the vibration carry you. The lullaby isn't cruel after all. It's merciful. It gives you permission to stop moving. For the first time since the Big Bang, stillness feels honest. You're barely moving now, or maybe motion itself has stopped having meaning. The last stretches of expanding space slide beneath you in a glide so slow it feels like waiting for a thought to finish forming. Ahead, a glow smaller than a sigh, the faintest ember of mass still clinging to itself. You recognize the shape immediately. It's the last kind of structure that can still claim a story. You're approaching the final act of gravity, when even black holes sigh. The nearest one isn't large anymore. A few 100 billion years ago it was a monster, the heart of a galaxy, swallowing stars like snacks. Now its event horizon could fit inside a planetary orbit. Hawking radiation has been eroding it grain by grain, quantum by quantum. Every burst of light that escapes is a confession written in heat. You drift close enough to see the faint halo. Nothing like the furious accretion disks of youth, just a ghostly sphere of microwaves whispering into the void. A mainstream historical fact floats through your memory. In 1974, Stephen Hawking published the equation showing that black holes radiate with a temperature inversely proportional to their mass. Small ones evaporate faster, big ones linger. Historians still argue whether he expected the result to be real or just elegant. Either way, he handed the universe its exit strategy. The radiation comes in soft pulses, photons, neutrinos, the occasional graviton if the equations are honest. Each pulse carries away a little more of the hole's mass, a little more of the information tangled in its horizon. The paradox that once kept physicists awake has long since resolved itself in the simplest way possible. Time. Given enough of it, Every disagreement evaporates. You hover at the horizon's edge. The temperature here is absurdly low, fractions of a Kelvin, but in this otherwise frozen universe it feels like standing beside a campfire. You extend your awareness, feel the slow release of energy. An atom's worth every few thousand years, maybe less. Still, it's light, and you bask in it the way early creatures once basked in the sun. Around you drift the remains of other black holes, their deaths staggered across uncountable eons. Some are already gone, leaving only the gentle ripple of their final evaporation. You imagine each as a candle snuffed by patience, its smoke turning into photons that will never find a surface to warm. A faint vibration passes through the dark, the ringing note of space-time settling after a collapse. The waveform stretches across billions of light years, a single bass note played on the strings of existence. You think of LIGO, the human experiment that first caught such a note back in 2015, translating it into a sound you could actually hear, a chirp from colliding black holes. That first detection was celebration, not elegy, but the tone was the same. Gravity sings in every key. Closer to you, the black hole begins to shimmer, its mass dropping faster as it grows smaller. Hawking radiation feeds on itself. The less it weighs, the hotter it gets. You watch the process accelerate, a slow crescendo spread over trillions of years compressed in your perception to moments. The temperature rises, the halo brightens, colours sliding from microwave to visible to gamma. It's as if the universe saved all its remaining drama for this final solo. A soft laugh escapes you. So this is how you do curtain calls, Entropy chuckles back, delighted. You've kept your sense of humour this long. For an instant, if instant still exists, the black hole flares brilliant white, pure radiation cascading outward. The horizon shrinks to nothing, and suddenly there's only light, expanding in all directions. No explosion, no bang, just a steady blooming that becomes transparency itself. The photons rush past you like a tide of invisible applause. You follow the wave as it thins into the cosmic dark. Each photon stretches, cools, lengthens into radio, then into nothing your senses can track. The last traces of structure dissolve into uniform energy. Space no longer has hot or cold, bright or dim. Every direction, every distance, the same. Equilibrium finally achieved. For the first time, entropy hesitates. There's nowhere else to go. The gradient is flat, the game complete. Yet the universe doesn't end with a period. It ends with an ellipsis. Quantum fluctuations still tremble faintly. Small rebellions against perfection. Absolute stillness is illegal. Even entropy needs a heartbeat. You drift through the empty glow, trying to decide whether this counts as peace or loneliness. The answer arrives as feeling, not words. Both. Peace because nothing suffers, loneliness because nothing changes. The universe has entered the long silence after the last note, where the echo itself becomes music. A quirky historical tidbit arrives unbidden. In 2019, humanity's Event Horizon Telescope captured the first image of a black hole's shadow, a fuzzy orange ring that everyone mistook for the eye of God. You remember the applause, the awe, the memes. None of those people knew they were seeing the prototype of this quiet ending. The image was never a warning. It was a lullaby score written in radio waves. You smile, remembering laughter, conversation, warmth. Every sound you ever heard was just organized vibration, every word a local negation of entropy. Now the silence is absolute, but it carries the memory of all those little rebellions. The cosmos hasn't forgotten, it's just archived them in wavelengths too long to fit inside any mind. One last gentle joke slips through your thoughts. Turns out the universe can keep a secret. It just waits 40 quintillion years before telling no one. Somewhere in the deep dark, the last gamma photon flickers a scent. You close what's left of your senses and let the equilibrium absorb you. The final black hole sigh fades into the universal hum, and that hum levels into smoothness. Heat death has arrived, not as a verdict, but as a lull. Nothing hurts, nothing happens, nothing needs to. You inhale, or imagine you do, and feel the residual warmth of all that ever was, spread evenly across infinity. Entropy hums its final chord, rich and quiet. The sound doesn't stop. It just slows beyond perception, a tone that will last forever because forever no longer has edges. The chord lingers. It's a low, endless vibration that fills everything and nothing at once. You can't tell whether you're hearing it, feeling it, or simply remembering the idea of sound. It's the same tone that started at the birth of time, stretched thin across eternity until it became silence. The universe has finally evened out, but even here, at the edge of what can be called edge, there's still one last act to perform. Welcome to Entropy's after party, where not even nothing is entirely empty. You open your eyes, though eyes are a metaphor at this point, and see uniformity. Every cubic meter of space holds the same thin drizzle of low-energy photons and leptons. The temperature hovers just above absolute zero, a number so small it makes the concept of cold seem pretentious. The gradient between any 2 points is indistinguishable. Work, in the thermodynamic sense, has retired permanently. Everything that could happen has happened, and what remains is diffusion with impeccable manners. At first glance, it feels like an ending, but then you notice something subtle. Space is not static, it's quivering. The quantum fields that underpin reality are still busy, jittering infinitesimally, birthing and annihilating particle pairs that never quite make it into existence. 0-point energy, the restless residue of being, refuses to vanish. Entropy can smooth the universe, but it can't cancel curiosity from the vacuum itself. You drift through these faint flickers. Each is brief, delicate, absurdly brave. A particle-antiparticle pair appears, holds hands for a moment, and disappears in perfect symmetry. It's the smallest play ever written, performed endlessly for no audience. You feel like applauding, but even the concept of clapping has lost physical meaning. The gesture instead becomes a thought, a little ripple in probability. And that's when it happens, when you realize the secret that entropy's been hinting at since the very beginning. This isn't death, it's balance. Every loss has been an exchange, every decay, a translation. The universe didn't fade away, it translated itself into a language too even, too soft, too complete for us to pronounce. The quiet isn't absence, it's fluency. A mainstream historical fact drifts by like a message in a bottle. Physicists once calculated the entropy of the observable universe at roughly Boltzmann units. That's a 1 followed by 104 zeros, so large it might as well be the word forever written in math. Historians still argue whether that number describes an ending or a reset condition. Some say heat death is final. Others insist that quantum fluctuations will eventually trigger a new inflationary burst, a new Big Bang. They're all correct in spirit. Nothing truly stops. It just loops in disguise. You stretch your awareness wider, and sure enough, you catch it. A slight rise in the field, a tremor in the smoothness. Somewhere, out in the endless expanse, entropy has found a loophole. A region of vacuum fluctuates upward in energy, forming a tiny bubble of false vacuum, unstable, glowing faintly. Inside, space is denser, hotter, rawer. It's a newborn instability, a seed of potential. You watch as it begins to inflate, exponentially fast, pulling its own space along for the ride. There it is, the next beginning. Not here, not for you, but nearby enough that you can sense the math. Inflation, expansion, heat, fusion, light. A universe rebooting not out of intention but inevitability. Entropy, paradoxically, spawning fresh low-entropy conditions by extending the definition of system. You smile. The universe is playing 4D chess with itself and always winning. The new bubble expands beyond your sight. You can almost hear it, the roar of a new Big Bang muffled by the infinite vacuum between. Its timeline will grow its own galaxies, its own laws, maybe even its own word for coffee. Somewhere in another 13.8 billion years of local time, someone will look up at a night sky and wonder if their universe is dying too. You wish you could tell them, don't worry, it's just recycling. You drift closer to the edge of your own fading cosmos, to the place where smoothness ends and potential begins. The old light, stretched into oblivion, gently merges with the brightness of the newborn region. The boundary isn't sharp, it's a gradient, entropy's favourite shape. For an instant you feel both sides at once, the calm of death and the rush of creation. It's the most beautiful contradiction you've ever known. A soft voice, entropy's or maybe your own, whispers through the vibration. You see now, I don't destroy, I redistribute. You laugh quietly, because of course it's true. From melting ice to dying suns, from civilizations to cosmic cycles, it's always been redistribution. Heat becomes light, light becomes structure, structure becomes dust, dust becomes memory, memory becomes silence, silence becomes the seed of new motion. The loop is flawless. A small playful thought drifts by. Maybe this is how the universe dreams. You grin at your own audacity, but you mean it. The bubbling new region, the rippling vacuum, the echo of long-vanished stars, it all feels less like machinery and more like imagination. The cosmos is dreaming itself awake again, and you're still inside the dream. You linger at the threshold, content to fade as the cycle turns. The last photons of your universe stretch to infinity, blending into the new light. You can't tell where one ends and the other begins. Maybe there is no boundary at all, just one endless gradient of becoming. Entropy's handwriting smooth and endless. You whisper your final observation into the quiet. Nothing ends, it just changes temperature. The vacuum hums back approval, a soundless applause carried on the last shiver of quantum life. And then, with a grace that feels almost affectionate, the old universe exhales. The background glow dims, the fields settle, and everything, every story, every atom, every heartbeat, folds into symmetry so complete it's indistinguishable from peace. You drift into that stillness, a final ripple in the grand equation. The last thing you sense before all gradients vanish is warmth. Not heat, but belonging. The feeling of having witnessed everything unwind exactly as it was meant to. The sound fades, the light evens out, and for the briefest, brightest moment before new creation begins, you understand. Entropy is not the enemy of life. It's the reason there was ever life to begin with,